Okay, we are live for day 12 of Advent of Code. And we do have a little bit of time. So I think we could do a little bit of a review of day 11. Possibly look into some day 10 solutions. Day 10 had a lot of variety in approaches you could take. I'm curious to see what people did there. Um, but let's start with just a recap of what happened yesterday. So I was able to clean up my code down to this. It's fairly compact. Um, the key here is I get these sets of which x coordinates are occupied by anything, and same with y. And now I just take whatever points I'm looking between, and I find the range of indices between them. And I'm able to do this by creating my bounding. This is my area type. An area just essentially has an x range and a y range, right? So if I make a bounding area around my 2 points, then I can extract the x range from that and just count how many of those indices are not occupied. Similarly for y range. And then I just use my normal Manhattan distance function. Oh, sweet radish. Finally learned the lesson and changed my template to use long instead of int. Yes, that's important. That's still a lesson I haven't quite learned. I have learned to spot it sooner and know like as I was typing this one up yesterday, I was like, oh, that's gonna overflow, isn't it? And I think I even did a check. I did a check if any of the individual ones seem to have overflowed into like a negative. Um, and then I summed it up and submitted it anyway. Without, I should just do a map too long and then sum it up first as my first attempt. Yeah, change templates to use long. Alternatively, like what I have here, I I sometimes use a numeric type, right? So in particular, say my interval type, right? This will work on a big int if that's ever necessary, but it'll also work by default on just a normal int if that's what you pass to it when you're creating it. But I need to make more of my stuff generic. My points here, they assume int. The problem with using long everywhere by default is when you're, say, indexing into stuff, indices are always expected to be ints, right? And you're not going to have a vector, for example, of more than 4 billion elements. So, mhm. Mhm. uh, generics, generics in a sense. So this is almost generics. Here I'm using, it's what's called type classes. So I can explain that real quick. Um, right, so there's an n, but for n, we need like an evidence that it's an integral type. And an integral defines things you can do with that type. It's like a trait, like an interface. But it's not it's not quite just a generic. Type classes give you a bit more like plug and play flexibility. If you have a language that is able to use type classes, it's definitely worth looking into. So Scala and Haskell. I don't know if Rust can do it. I don't think Rust can do it. Um, I wonder if OCaml can. They might have opted not to. But yeah, basically this is just evidencing my n type is an integral and you can do things with integral types. I don't know why your chat is showing up so late here. I'm just giving myself a quick refresh. We want that working properly. When the problem actually drops. Yeah, so day 11 ended up being pretty simple. Just get all the combinations. This is a built-in library method. So all the combinations of 2 elements and do our dist function, which just sees our built-in, or like our default Manhattan distance, plus count the empties and multiply them depending on your growth factor. Um, so I want to see what other people did, and I have that up here. Um, So this is from Seth Tissue. He defines a point type in a Manhattan distance. Oh yeah, that's just your messages showing up twice. Um, and expand. So he takes the universe and returns a new universe, and this is a secret positions. Okay. Okay, so he doesn't use just a grid. So I think that was one part that made this easier for me. I didn't use this grid and like make it larger. It's a sparse grid, so I just kept a collection of all the points. And it seems that's what he does here, but he does modify the point locations when he does this expand. So we look. Oh, sweet radish, your code. I'll be excited to look at that. Um, yes, I'll pull that up after this. So he finds max rows. He finds all the empty rows. Okay, the point is that he has the all the indices are empty, and for row and column universe yield factor minus one times. Okay, it's similar to what I'm doing. So empty rows that count, and you count all of them that are less than this row. So essentially, he just does as a pre-computation, which honestly I think would be more efficient than mine because you calculate their expanded positions first, and you aren't necessarily doing a like expansion calculation for the same point multiple times, right? And then all distances sum. So wait, first we yeah, this is fairly straightforward. Um, I like this approach algorithmically. I still do like my own code here. It's gotten pretty. Of course, I have like library methods I'm using, but still it feels nice and compact, readable to me. Um, Sweet radish. Let's look at yours. Oh, let me copy that link. Okay, this is in Java, and what did he do? So Boolean row has a galaxy. Okay, so you do check which rows and columns have galaxies. Um, and then expansion. So you have your input. Are you expanding the actual? You're not. There's no way. No one's expanding the actual grid. Um, so previous. So you look at your row prefix, and if it has a galaxy, one. Otherwise, the expansion. Okay, so you keep adding the expansion for column then. Okay. I mean, prefix sum seems like a reasonable way to do this too, right? That essentially caches a lot of this. Like both yours and Seth's would be more like algorithmically efficient than mine in that sense there. Um, yeah, exactly. Okay, cool. Makes perfect sense. I wonder if I'd tried a prefix, what would it look like? In Scala, you might like this if I can convert you someday. There's um there's a method. So let's say I have like a collection 1 to 10. There's a scan left, which computes prefix sums. So let's say I start with 0, and at each point we just take whatever we have and add to the new element coming in. So this, for example, gives you the running prefix sums right there as one line. And of course, I can turn into many different functions. I think that came in handy a couple of days ago with, is it, is it even day 9? I don't know. There was a scan left in here somewhere. Mm, maybe it's day 8. Yeah. So I used a prefix for my decisions, and I was able to scan left. In this case, I was able to scan left on an infinite direction list because they cycle, right? And then at each point, I take whatever I am at currently, and then I move based on the new direction that's given to me. And then this gives me another infinite connection with which I could do. I could search beyond just one cycle of directions, which might have been the case, but wasn't the case. So this was unnecessary, right? Like this could actually just be a fold left and take the last element and not use infinite directions. Um, but there it is. All right. Uh, what else do we have? Here, the line inflated. Okay, you inflate lines. You inflate a line, seek a string, you return a new string. Oh, so this is taking strings and turning them into larger strings, which I don't know how that works for part 2. Because then they'd get pretty large, yeah? Maybe I'm misunderstanding this. Inflate line. If there is what is LL? I'm not sure. Oh yeah, okay. Right, that's the parameter. Um okay, I am struggling following this one a little bit, but it's probably a similar idea. And I think this is the person leading the leaderboard right now. They've been pretty fast in the last few days. Okay, so expanded lines to array, map to array. Wait, what's this expand method? I'm going to assume. Oh, they transpose. So right, they just have an expand row function. They are filling it though. So they're making. Are they actually making pretty large arrays? So k equals. Right, so we saw this with k equals 1,000,000. And then what does k end up getting used? Oh, I suppose they count i's k else 1. Okay, right. So they just sum all these, and they might sum k's. Okay, so they aren't actually expanding. Well, hold on. If the row has, otherwise you have an array filled with stars. Why would you just fill it with stars? Oh, that's an interesting approach. So they just turn it into like a lattice. Huh. And then I suppose that makes some of the computation here simpler. Right, if expanded at that point has a star. So that's their way of checking if a column or something has a star. They just fill up the stars vertically and horizontally. And if it does have a star, then you just use k else 1. Okay, that makes sense. Seems slightly unorthodox, but I dig it. Okay. Well, anyway, I think I should do a little bit of warm up. And for today's warm up, why don't we look at like 2022, day 11? Um, to day 11, or maybe let's do day 12. Hill climbing algorithm. We haven't had to do like a Dijkstra of some sort yet. So why don't we solve this one? Do I have a warm up file? Um, let's just go to our day 12 worksheet and let's save this as a warm up. And we can just keep reusing this warm up worksheet. So let's get 2022, day 12. And we do have a grid here. We start at an S, we're looking for an E, and we're climbing. I already know this problem. I remember this from last year, but we're climbing from A to B to C. From C, you can only go up to a D, and you can drop down any amount. And what is the question was a few steps required to move from your current position. Okay, and this is flood fill until we reach E, and then the number of steps in that flood fill. So about area equals area, that input that might come into handy. And then we need a start location. Val start equals area input is equal to the character S. So we have a start point, which is 0, 20. And well, we have a search step. So it's just, we can define a search step, or we can just go straight into the full search algorithm. And I think I'll just do that. Iterator.unfold. So we have a start location. This is my standard flood fill algorithm. So I'll just do set.empty point. This is my visited, and this is my current visiting, which is going to be set of start. So case visit, it knows my code. It knows my code by now. Great. So this is almost there. Surely it learned this from my code, right? Except this isn't exactly my code. So we will return current. So this will return like a set of an iterator of sets of points. So yeah, we'll return current, and our new visit just becomes the current. So it's right that yes, visit technically has both of those combined, but there's no need to add this. It's sufficient to have the ones that were visited in the last step to prevent yourself from accidentally like looping infinitely backwards. So we'll just say current becomes a new visited, and next becomes a new current. And then ands1 equals, we'll call this steps here, valid steps, or def rather, because it's an iterator, and we don't want to accidentally consume it. So steps dot index where it contains the E. Okay. Now that's almost the answer. This is just a straight flood fill, but our flood fill has rules. So after this flat map here, I have like another filter knot. So we'll just put these in lines here. So flat map adjacent. And then we're going to filter whatever a current element is So this is a set of points for each set of points, not just we need our own adjacent function. So given a point, and then let's say given an area, why not? And we'll just replace this area.adjacent call. Return a set of points, and we'll start with like a area adjacent to this point. Okay, wait. Let's call it P. And then we have to filter, and the input of, let's see, it's climbable. So it's climbable if the letter is one above the current level, except in the cases of like S and E. So let's get like an elevation function. So def height of a character. Uh, yeah, so C some character, and we'll do like an int. And if C is S, then I guess we could have that be 0. Else if, um, otherwise we take like, I think we do a match, C match. It's a case S, and we return 0. Case E is the maximum height Z. So we'll do Z minus 26, I suppose, plus 1. That might be wrong. I'll hold that thought there. So C gonna be like C minus A. And then I do have to add 1 because we don't want that A to go to 0, right? Because S is 0. Okay, and then so here we do a similar thing. We're gonna do Z. We're gonna subtract A to normalize, and then plus 1. Ugh, this is the kind of, I don't like this function. I should have written this in a different way. I hate doing this like plus 1 minus 1 math. It's not clear to read and debug, but we are already there. So Z, we do a plus 1 minus A plus 1 to normalize. That's just our normal normalizing function. Yeah. In fact, you know what an easier way around all this is? I'm just going to scrap all that. We're going to do A minus 1. And then for C, we just return C. We'll just cast that C to an int, right? So if we do like A dot to int, and then here we'll just do Z plus 1, right? And then now height of S is going to be 96. That's what we want. We don't have to normalize to 0. We just need them to be one higher than the other. Okay, so back to this adjacent function. Area.adjacent P dot filter. So we have some Q, and height Q is less than or equal to height of P. Oh, you know what? Let's just make this a point. P point, and then we'll take input at P, and that's what we'll match on. Yeah. So height of Q is less than or equal to height of P plus 1. That is our condition. And now we just replace that down here. Adjacent. And we just pass along the area. And I get 352. My puzzle answer is 350. So we have a slight bug in there. I think this is an off by 1. on the index where, so let's say the first element s, that is 0 steps taken, so that should match. Um, hmm, let's print the first few. So steps that take um, yeah, 10, and for each print line. We start with 0, 20. This index here would be 0, right? This is one step, and we have 2 points that we can walk to. Um, and so forth. It's like growing over time. Um, I could make a viz for this. I don't feel like I really need to debug it. Hmm, maybe I'm missing something. The puzzle answer is 3. This would be a good exercise in debugging. But what I think I'm gonna do is just look at day 12 last year. Val ends 1. Okay, so we do our flood fill from source, which is set points, which is just a start in this case, and an index where contains end. End here being, oh, the end point. Okay, so like our final function here is similar. The points is defined as, oh, interesting. So our oh yeah, sure. We're just finding a start point, end point, etc. Our flood fill function. Let's see how that differs, because that's probably where it is, right? Let's pull up our warm up, and on the right is last year's code. So there's the flood fill. So again, empty point, source set of points, visited, last visiting, or visited last and visiting currently. You know what? I kind of like that naming scheme better than what I have here. So I say visited, which doesn't make it clear that it's just the ones that are visited on the last step. I think I'll adopt this naming convention in the future because I prefer that. Okay, on current empty, and then we have next visiting flat map adjacent that filter, and then we look at the elevation. So here I have my filter up above. So elevation is less than or equal to elevation of the original point plus 1. So we have the same condition there. I do kind of like that a little bit better. So we could do like area dot adjacent for that point, and then we have a filter in here, right? That's how we'd make this similar, and then that filter would precisely be this here. But then we need to have the P passed along. Anyway, we're not going to do that. I'm happy that they are the same. Filter not visited. This could also be just a diff, right? I think filter not just defaults to a diff. Current goes to current next. This is almost exactly the same code. It's almost exactly the same code. Why are we getting different answers? Let's check the height. Okay, so elevation. Oh wait, S. S is the same elevation as an A. I see. E is so that's a misunderstanding of the problem. We didn't need to do A plus 1, and we didn't need to do Z plus 1. Okay. Yeah, that gets us 350. I see. And then for part two, we have 15 minutes left. So part two, if I remember correctly, we just have a different set of starting numbers. Um, Maximize the trail should start as low as possible. Elevation A. The goal is still the marked. So we need the shortest path from any elevation at A to the square marked E. Um, so ends two. This steps here is going to have to be turned into a function. So let's turn. Well, I mean it is a function, but we need a parameter. So we'll have a starting set of points. Yeah. And now our starting set of points here. Okay, well, steps from set. Oh, wait. You don't need to turn that into set. You just pass it along. The stat of the start point and val p2. Well, we'll just call it starts. Starts is going to be filter. Oh, how does it know? Height of p is equal to a. That will also capture the s. Okay. Yeah. I'm gonna turn that into a set, and then now we do step from starts. Oh, this is ends two. And what do we get? We get 349. And yes, the answer was 349. Okay, that felt good for a warm up. How long did it take me to do that? That took me 27 minutes, ish. I think it. Can't remember exactly when I started. What did it take me last year? So 2022. Last year, it took me 33 minutes to get through all of that. 25 minutes for part one, and then like a 5-minute delta. I feel like the delta here was shorter. And of course, I did peak the wisdom from last year. Realized I was misunderstanding the problem. So probably pretty even with last year. Like if I spent more time reading the problem, it would match up. Hmm. Okay. Well, we still have 12 minutes. I feel warmed up enough. Maybe what I might do is look at more of my library codes. I have ideas for things that might happen. Um, A12, yeah. So now we have this area that I've been working with, and as I've done with the interval, where I can take like intersections and whatnot, you could take intersections of two areas, and in most cases, it might be just another area, right? It could be an empty area. It could be an empty area. Hmm. So let's define that. It might come in handy either as like part of a larger algorithm or maybe like a problem ends up explicitly wanting intersections of areas. So let's add that. Def intersect some other area A, option of area. How does it know? X range to intersect. This isn't quite what I want because ranges don't intersect properly. So we're gonna do like interval from the X range. Intersect the interval. I might rename interval to like span for no other reason that it's shorter. A.x range. And then we do two range, right? That's okay. When I intersect two intervals, I get an option of an interval, right? So if that exists, I'm going to put this in a for comprehension. So for, uh, and this is the x intersection, the potential x range, right? Um, and then similar code for the y range. And then we're going to yield. So if both of those exist, then we convert those to ranges, and that's it. That's very simple code. I wonder if I should just represent my areas in terms of my own interval type. Hmm. But then when I use as utility, I'll have to convert my interval back to a normal range. Maybe, might not have to. I think before I do that, I have to give my interval more methods to have it be on par with the range. That way I don't have to think about converting it all the time. I might like implement ccops. Let's write some tests for that just to see it working. So there's point tests. At some point, I should move this to like its own area tests file. So here are some area tests. We have this. Hmm, let's see. I'll just put area intersection tests here. One of these days, I'll organize these tests. So val a equals area. Sure. We'll call it area 1, val area 2, and then area 1 dot intersect area 2. We get the range 1 to 2. That makes perfect sense. I might just shift one of these over. So maybe the y range goes from 2 to 4. That way we know x and y are doing different things. Yeah, 1 to 2, range 2 to 2. Right, now the size of this be 2 by 1. Oh, interesting. 1 to 2. Oh, wait. The size of the option is rather. We should be able to get that, and then not get that size. And do completely disjoint. So about area 3, let's do area 3 to 4 and 3 to 4, sure. So area 1 dot intersect area 3 dot is empty. Right, and that can be an assert. Okay. Diffing areas might get a little bit trickier. We might want to be able to subtract one area from another. And in this case, you potentially run into 8 areas, right? Like if you remove a square from the middle of a larger square, then you could represent that remaining square with a hole in it with 8 squares. And I have a way for that. F intersect. So let's give it a shot right now. We have 5 minutes. Oh, it knows what I want to do. It knows what I want to do. Okay, so for um, x intervals, yes. Okay, right. This diff returns a list of intervals, and then we yield. So all those y intervals, one of those intervals are going to be the area that was just removed. So we need to filter it out. So if um, A is not equal to the area made from x interval dot to range and y interval dot to range, then, well, let's define A actually. A equals, we have some other area. Um, I know, interval area. And if A, the A that we're diffing is not equal to, well, it could also be the area that you're subtracting. Yeah, the area that you're subtracting could very well be one of these, right? So as long as that is not equal to this interval area, yield that interval area. Okay, and let's test this. Area diff. So, well, large area. How about more like 0 to 10? Well, mid area. We can do like an area. Yeah, exactly that. Let's try large area dot diff mid area. Oh, interesting. We could do the size, and it should be large area dot size minus mid area dot size. So these two should be the same. 96. Oh, wait. You want to map dot size. That map dot sum. That should also be, that's not quite right. So let's look at what these are. Okay, so we have the range 0 to 2, 0 to 2, 0 to 2, 8 to 10. Oh, we don't have, what we have are the four corners. We don't have the side areas. Okay, so we will have to debug that later because that is my alarm for advent of code. I will say, these are just the four corners. Maybe I echo that to do over in this file here, and I'm sure we'll find a fix for that. So let's open up my file for today. So day 12, 2023. Then we have advent of code up. And I kind of want to pee. I kind of don't have time, so I'll just have to finish the problem very quickly tonight. Hmm. 20 seconds. Maybe I'll just like take a quick look at the leaderboards. I could top the Scala leaderboard. I'm fast enough today. I am catching back up. Okay. This is interesting. So we have a bunch of symbols and a comma separated list of numbers. We reached the hot springs. We are having a lava shortage. All of Gear Island is currently offline. see why the lava stopped flowing, we have to find a spring that can launch you up there. Okay. Uh, they are not sure which springs are safe to use, yet their condition records of which springs are damaged. Okay. Wait, worse yet, their condition records of which springs are damaged are also damaged. So these condition records are damaged. Okay, some springs are damaged. Um, so this is like an error correcting code kind of thing, maybe. In the giant field outside, the springs are arranged into rows. For each row, the condition record shows every spring and whether it's operational or damaged. Okay, so those are my springs, operational or damaged. This is a part of the condition. This is the part of the condition record that is itself damaged, or on some springs is simply unknown. Okay, so we have a ternary or a trillion. What's that boolean with three elements? However, as produced, the condition records also duplicated. Some of it is in a different format. So that's what is to the right then. After a list of springs for a given row, the size of each contiguous group of damaged springs. Okay. Is listed in the order those groups appear in each row. This list accounts for every damaged spring, and each number is the entire size of its contiguous group, as groups are always separated by at least one operational spring. This would be 4. That means damage. Okay, so this 113 makes sense. This is also a 113 case. Yeah. But in this case here, basically in this space, we have to discover 2 springs. Here, now here, there are multiple options, right? Right, like this could be the damaged spring, this could be the damaged spring. Okay, so we might not need to figure out what's the final question. For each row, count all of the different arrangements, all the different possible arrangements of operational and broken springs that meet the given criteria. What's the sum of those counts? I wonder if we can brute force this. Like for this there's only one possible arrangement. Yeah, so we could brute force. How big is the input? So input dot size. Hold on, I want you to refresh that. Hold on, did I not download it? Oh, okay. I cannot overwrite. I'm surprised by that. I thought I'd change that in my function. So we remove that and we rewrite this. Okay. So there are 1,000 of these. And for each of these, like these chunks, I wonder what the biggest chunk is. Because this could be like a chunk of 4. It could mean like 4 choose 2 or something like that. Or no, it'd be like 2 to the n if we were just really going after every possibility. So I think we have to do more narrowing than that. We can't just brute force it. Okay, this might be one where we want to work with this example right off the bat. Which is the example for which they give us answers? Adding all the possible arrangements together. I think this is this example up here. Yeah. So we're going to copy that. Day 12, 2023. This is a judgment call here. My judgment is I want to debug somewhat. But also let's look at day 12 text. 1, 2, 3, 4, 5, 6, 7, 8. Like some of these are pretty large. Oh, yes. Good point. Thank you. This is actually that. We want question marks in here. Okay. And then we'll solve one of these. Yeah, and we could use each of these in turn as an example. So day 12, actually 2023. Um, so def, we have two things, and we need to count solutions. Um, Given a list of spring conditions, wait, conditions, and this is going to be like, we're going to do a vector of cars for now. Or honestly, like this is fine as a string. And then we have a list of int, and this is called like a contiguous damaged, and then we're gonna return int. And I see myself like breaking this down further, but not right now. We'll see. We'll see that as it comes. Um, hmm. Now let's think about some of these cases. So in this one here, there is only one. So in this case, like we're able to determine like, okay, we need three, choose two such that they aren't adjacent, which is also like three, choose one, like one point to be a boundary, and it can't be this here. Oh, this is a combinatorics thing I am missing. It's not quite that simple. Maybe in a bigger example, we'll see this. So here, two choose one, two choose one. We have to determine that they have to be in this group and that group. Now here, 1, 3, 1, 6. So we need a group of three damaged. So like this first one can't have anything beside it, right? So we can determine stuff like that. Um, we can say that's determined, and then we could go recursively, right? Then we could say like this here is 3, 1, 6. And if the first thing has to be 3, then there will be those three, right? And then it has to have a space afterwards. So we could say now this needs to be 1, 6. And then at this point, there's only one solution. Okay, so we can break them off in chunks from left to right. Um, yeah, we could do this with some sort of backtracking search, right? Like maybe there's an opportunity that this is undamaged, and then we search here, and then we realize, oh, there's no opportunity because that relies on this one being damaged. Okay, so we'll have a recursive count solutions solution here. Um, so let's match on contiguous damaged. And if it's nil, in this case, you only have one solution, right? And oh, now we have to try and match this to the start of the string. Um, to the unknown locations. We could do a match on the string itself. So we could do conditions match, right? So if it starts with if it starts with question mark, for example, and then we have remaining. And I don't like calling this x and x's. Let's say D and D's for damaged. this might not be 1. Might actually be 0, depending. But we'll think about that when we get there. Um, and we could search for like a whole block at once. So depending on where D is, because we would have to handle all of D in this one round, right? This is what the next one should be. We have a few conditions that will like early terminate this. Let's write those out. So if um, conditions that take while it's equal to this. So for example, if that is just equal to D, then we can recurse. So in that case, we have then we recurse, and we're gonna remove condition dot drop the +1. The next part would have to be so this has a secondary condition here. So this is gonna be like and conditions at D +1 is equal to a space. Then we can drop D +1 in our recursive call. So count solutions. And then pass on the remaining ds, right? Okay. Of course, else, in this case becomes everything else. I don't like whatever that autocomplete is, so we're just going to delete that right now. Yeah, and we keep searching from the left. Another simple case is if it starts with an undamaged spring, then we know right? Like in this case, while we're doing the search, or like even in this case here, let's look at this. Think about this 165 here. We already have a 6, we already have a 5. So this question mark, you can recurse and have 165 on just this string here. Or you could recurse consume that 1, and then now we have 6, 5. I think it would help a short circuit knowing that there was already a group of 6 and 5 later on. Because otherwise, like what we might try to do is search for a group of 6 here. And maybe it's not too important to short circuit, right? Like we just try each of these and then we back off. So if I'm kind of tempted to turn this conditions back into like a list of something so I can match on it. And let's say we were to write this in such a way that we can do a character by character match. So if we are doing a character by character match, then are we always going to assume say, right, like here, we have to start with a 4. If we do a character by character match, then we could like consume one of the 4. But then the next one would have to start with 3. And we'd have to just sort of know that. There's not really a nice way of knowing that. Okay, so there are two conditions in which we could just take all of the next 4. It is when they're all like that, or it's when they are a mix of the pounds and the question marks. Yeah, before I do this, I might do like a little parsing into enums here. Turn that into a list that I can match on it. And then I could just say, what's one of those? We're just gonna do this, which is we're gonna take it if it's either a question mark. So take while the string of pound or question mark contains. And I'm thinking we might actually end up doing like a span of this. Um, so we have like the matchable portion, and then we have like the rest. And then this is a conditions.span. And then now the secondary bit here can be like an if else check on the rest. So if rest dot head um, yes, it could be a head option. So if rest dot head option contains question mark, this is a head option of character. Yeah, then rest dot drop and ds. That works. That recurses. So that handles both of these cases I started writing here. And otherwise, we can't continue matching. So this is also like an addition, right? Um, so where do we start like adding these solutions? Maybe we just like return all of these solutions. We're not even sure this is a solution yet. So like we recursively count solutions on this. And I think regardless of this, we still might recursively count solutions. On yeah, so we're gonna add this to something. So val, I don't know. Let me call this x for now. The point is that we're adding this x plus count solutions where we don't consume these. So rest.drop one exactly. Uh, it could matter. It could matter if one is a damaged bit. So we could drop until it's not a damaged bit. We have to go past all the damaged bits we see so far. So let's do that. All the definite damaged bits. And what do we call all of these remaining bits? We're gonna call this unmatched instead of rest. If you have unmatched head option contains I guess if it contains a question mark, it can contain a question mark or a fixed gear. And in either case, we would then drop it. Um, let's do this. For all, the string question mark or dot contains it. And we'll call this, yeah, we'll call this match solutions. And we're going to add that to something. So now we have damage start. Um, and then we have like unknown after damage. But if it starts with damage, if it does start with damage, then we do have to match it, don't we? And we can't just recurse and ignore that. So we can only continue if it's a question mark start. Right? We can only continue if it's a question mark start or an undamaged start. Yeah, so let's think about that. That's gonna be something like conditions.span, and it's gonna be question mark or dot contains. Right. So this is because we're assuming it's an undamaged start. That question mark is going to turn into a dot. And for each of those, we can recurse, but I think it's only necessary to recurse down one level. Yeah, I think the only reason we started thinking about doing a span was because we might take all of the leading damaged. So basically we can recurse if conditions dot start it starts with, or say conditions dot adoption dot fall. Um, then we can recurse dropping that. Right? Then we need to add that to the match solutions. The unmatched solutions equals, and we're going to do this if check here. Great. So now we recurse, count solutions, conditions that drop one, sure. And then we have the same contiguous damaged. Otherwise, there are 0 options here. And then we add match solutions plus unmatched solutions. And honestly, that already seems fairly reasonable. Now, this nil case is all we have to think about. So, um, basically, I think this depends. So if we have, if conditions that for all, then it's just question mark or dot, and there are no more contiguous damages to match, then 1. Otherwise, it contains a damaged part, and this is a 0. And now this whole then. Okay, so if the unmatched part does not start with that, then there's no way to match this at all. At this point, we just return 0, right? Because if it's leading with damage, and let's say we match damage, and then we're not able to continue, then that just has to be a 0. Honestly, is that a solution? So let's count solutions for one of our test strings. So we're going to do input 0, or actually we still have to parse that. Parse a line of input, and it knows we want a list of string and int. So we're going to do line match. So what do these look like? We have a bunch of characters, and these are conditions, and there's a space, and then there's a comma separated list. So nums, and nums.split space, it's actually on a comma, like a split on a comma, to list.map to int. Okay, exactly. Okay, so now we can try that. Count solutions. And let's start with input line 1. Argument for parameter contiguous damage. Oh wait, we have to parse that. Yes. And right, we also have to untupled because we're passing in a tuple. How do we use that? Curried? No. Tupled. There we go. And we have an issue here. We need to write dot contains. Okay. Stack overflow error. That is not what we want, especially for such a small input. Just look at what we're seeing here. We get that string and we get the list 221. Wait, 221. Oh, we're not looking at the example. Okay, 113. Great. Now this thing has to keep getting smaller to make sure we're avoiding the. So when we run count solutions, we do drop one of the unmatched and we continue from there. And we continue with the thing we didn't match. Oh, we didn't do a check for if matchable is large enough. So that would happen here. So if okay, so if matchable.size is greater than or equal to d. I mean, if it's less than or equal to d, then we have to recurse, right? So let me put that in here first. That's not quite the recursion I want. We do count solutions. It's not going to be on unmatched. Well, okay, I mean, if matchable is too small, then we have to check if it's forcing us to match, right? So we have to like drop a question mark. So if it's less than or equal to d, then we have to do like conditions. And then we're going to span with this here. I think it's just the head option. It's just the head option case. It's this one right here, right? Then if it's less than D, then in this case here, wait. It's not quite the unmatched head option. So if it's less than D, we, we don't want to put that in there right yet. Then we first check if conditions head option is that, then we can count solutions dropping one with the same contiguous damage. Otherwise, there is no moving forward because it starts with a damaged piece and there isn't enough leeway to use one of these. Okay, but otherwise, wait, if matchable.size is, no, this is less than D, not less than or equal to D, right? Otherwise, you can match it. And in that case, it's not really going to be unmatched.hit option because we need to remove the matched part. So otherwise, here, we break in and then we have val matched is going to take 4. So we have conditions, well not 4 rather, but take. So take, there is like a split that gives me 2 split at. Yeah. So split at D. Let me just test this real quick. Make sure I'm doing it right. So let's use my name, Stewart.split at 4. And just give me 2 springs. The first string is length 4. Okay, so matched. And then now we'll call this unmatched. We're just going to shadow whatever was going on in there. And then now, if the unmatched part starts with something that can remain undamaged, then the match solutions is we count for the unmatched drop 1, the remaining Ds. And the unmatched solutions are the cases where, oh, did we need this? If conditions are head option, I think we're already thinking about this up here. Oh, I'm basically just kind of basically kind of like reshuffling things around here. But we do have to branch down both possibilities, right? So this is the case when you can't match anything at all. And now here's a case where you can match something. And basically the question is, can you choose also not to match it? And if you can also choose not to match it, you have this unmatched solutions here, where we take conditions, check if it begins with something that might not be damaged. And we count those solutions. Otherwise, there's no option. And we do like match solutions plus unmatched solutions. Else 0. Okay, that is like a gnarly bunch of if-else's, and I will want to refactor that one at some point. It does get the correct answer for the first line. And let's just do this for a few of these lines. So there's 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. Yeah. And some of those are not right. There's one arrangement for the first, 4 for the next. There should be one arrangement for this one, but we're getting 0. 1, we're going to do this, so equals 1, so we can see which is correct. These are our tests. equals 1 equals 4 equals 10. Oh, but now I can't see what it's actually returning. I'm just going to subtract that, and it should be 0. So let's do a bit of multi-line editing here. There we go. So this one, we know must be 1 higher than whatever it is, which is currently 0. So let's look at input line 2. Input 2. Okay, so we got a 0 out of this. Let's do some printing of these recursive calls. Yeah. I feel like we want some printing down in here. Let's start with this. Let's see how far we're recursing at least. We're going to count solutions at tuple parse 2. And it only gets called once, and it gives up. Okay, this thing is starting with a question mark. So what's going to happen? So we have, so we look at matchable and question mark. So there should be a, well, more than large enough matchable size. I'm thinking I don't actually need to span. I'll just leave a note. Only need to take the +1 elements, really. And then if matchable at size is less than D, well, okay, what happens in the case where we start with a question mark, right? We start with a question mark. Matchable in size is not less than D, so we're not going to even go into that branch. We're going to go in here. And we're going to have like a matched and unmatched. And if unmatched.head option, we're going to take D number of elements. And this first case, it's not going to work because it's going to start with a period. But, okay, wait, it starts with a question mark, sure. Okay, so we're going to go into here. And we have two options. We can attempt to match so we take the matched bit. So are we using the matched bit? Matched. This one right here. We're not really using it. So the matched solutions are where we count with unmatched, drop the first element, and this will result in 0. Right, so this should be a recursive call. I'm just going to do a print line test to make sure we even make here. Should be here. Okay, and let's look at this. Okay, should be here. Works. Yep, solutions where you matched it first, and this here should result in a it should be unmatchable. This should return us with a 0, right? We can do print line. Solutions where matched from start, and this can be just match solutions. and then the unmatched solutions. So if it starts with a question mark, which it does, we should go down here, right? Um, yeah, and print line where dropped D. Oh, wait. Conditions that drop one. No, dropped one from start. Um, yeah, let's see what prints in that case here. We didn't get anywhere in that if else branch. Um, Interesting. Did we just end up in the else branch? Yes, we ended up in the else branch. This else branch here isn't just zero. Because it could be the case that the matched bit, um, if matched, not for all, not even for all, right? If it starts with, if matched, that starts with a question mark, then we could recurse. So count solutions, and and then otherwise, it starts with a question mark. I'm not even gonna check the dot because matched is only going to be. Oh, hold on. This conditions that split at. We're not even checking that matched can match. But this whole if is if the matchable size. So you can match. So we know that you can match. Oh my god, I hate this FL branch so much. So if match starts with question mark, otherwise then the only option is that it starts with a damaged, in which case we cannot recurse that way. So we can drop one. Um, Match dot one plus unmatched, and then we have contiguous damaged, which has still not been spent. Right? Yeah. Okay. So hey, now we're getting correct answers. And it just fails at 10 because of Stack Overflow. Okay, great, but we're getting correct answers. So we have most of these cases. We just have some performance issues. I'm going to remove some of my print lines or comment them out rather. This is a working thing that might need to be refactored. In fact, I'm so kind of worried about it that I'm going to commit it for now. So this is day 12. Commit M partial. So 2023, day 12, partial working solution. Okay, and then we just need to figure this Stack Overflow. Um, and this isn't a large enough thing that it should Stack Overflow, right? So I think that's probably some sort of a error. Oh, yep. Here, see, we see ourselves printing the same thing over and over again. It's an infinite loop, not a performance issue. Okay, and what is it looping on exactly? Empty string and a list of one. Okay, so we need to match for that. Um, okay, one way to do this. Base nil. Um, we could match for the strings as well. We could do an if just wrap everything in an if. So if conditions that is empty, then this contiguous damage is empty, then 1, else 0. Right. Else we go into all of these. I'm just going to indent that a little bit more. That will fix that. Okay, so this works. The question is, will this work on the real input? Will it be performant enough? Anyway, for each row, count all the different arrangements. What is the sum of those counts? And we can do like input dot map RS map counts. Okay, yeah, exactly. That would get it. So 21 for this. And let's see if that works just fine for day 12. And that seems to. Okay, 7916. And I feel pretty confident that's it. Yep, that's the right answer. Cool. Part 2. You look at the field. Oh, I'm going to save this. So GAD, same thing. And 2023, day 12, part 1, solve on stream. Okay, sure. You feel like there are more springs in the condition record list. When you examine the records, you discover that they were actually folded up this whole time. Okay, so now we need performance. To unfold the records on each row, replace the list of spring conditions with 5 copies of itself, separated by question marks. Okay. So we're gonna call this parse 2. Def parse 2. So we're gonna like parse 1. So it's the same thing so far. So we have what is it? Conditions and contiguous damage, and it's parse line. And what we return is conditions. We repeat that. Let's look at new list dot fill 5 times with conditions and make string with a question mark. So that unfolds that. 5 copies of itself separated by question mark and replace the list contiguous groups of damaged springs by 5 copies of itself separated by. Okay. And this goes to contiguous damage or list.fill 5. List.fill 5 with contiguous damage and then dot flatten. Right, so that would parse it correctly. For part 1, oh, and then we're just gonna go back to the example. There's many more. There's many more. 16,000, 500,000. That's starting to get into Stack Overflow territory. I need to make this tail recursive. So val ends 2. Yep. So at some point, we can try this out for some of these individually. It is trying to compute that, right? Yeah, out of memory error, as expected. We don't want to uncomment all of these. The example, we still have one arrangement. Minus 16,384. That might be enough to kill me. 500. And then we have 506, 250. So we're going to comment out those larger lines and see if my logic at least works. This is parse 2 now. Um, hold on. Let's just add that in. Parse 2. Comment out the problematic ones. Maybe not that one. Okay, so that works fine. Let's see if this 2500 one will work. That works. The 16384 works. And this is the one that's not going to work. So my logic works. My parse2 function is correct. Okay, what prevents this from being tail recursive? Are we ever adding any? Yeah, we're adding matched solutions and unmatched solutions. Um, oh, I could have seen this coming. Okay, making this tail recursive. So in the case where we have to do both of these, mm, like maybe we have to be like smarter about this stuff here altogether. Okay, well I'm letting that chill. As in the 3000 range. A few people have already finished part 2. 3 people have already finished part 2. Let's see if I can be the 4th. Um, is it sufficient just to make this tail recursive? Because, like, in this case, there is a lot of, it's such a big row of question marks. Like, maybe just be like, smarter about that altogether. And I'm gonna commit because I'm kind of like worried about this one. Sure. Sure. This is the only place right here. This is the only place where we add 2, where tail recursion is thwarted. Uh, and is it always the case that we go branch down? There could be like some sort of, like maybe I can do some sort of memorization. So in 1, we drop a leading question mark. Right? Match dot drop 1. And then the other, we just drop the whole matchable region. In fact, like I think this works. We remove the period, right? We still have, I'm going to uncomment some of these. We're still getting a bunch of zeros, right? Yeah, like this can be period removed. I think this needs to have the dot in there. The conditions, we can just do like a starts with question mark, right? Starts with question mark. And that doesn't change anything. As 1 still works. Um, how do you make like a branching thing like this? Tail recursive. gonna have to like add a queue of things to check. And that queue could grow very big. Um, it would be that after a match solution, we could sequence these, right? Like after going for a matched solution, then we pass along like the continuation. Optional continuation being this. And then once we get to a solution here, it's not just 1 and 0. It's we check if there are others. That's so sketchy, but it's one way to do it. Uh, and avoids like me needing to rewrite altogether. Okay, I'm gonna have continue be like an option of string, and we're just gonna default it to none. Actually, I don't like defaulting it to none because I'm gonna forget to pass it to a recursive call. Okay, if conditions is empty or like if contiguous damage is nil, then we do have to check this. And like this thing has to be passed on. Right? This is sketchy, but might have to do it. So counted was option int. Right, we pass it back on. Okay, and then the 0 takes that counted if it exists. Well, okay, so we have this counted dot fold either 0 or wait C or plus C. And if there's a continue, this is sketchy. So if continue, empty on C2, otherwise count solutions continue dot get, it knows what I want to do. None with some C2. Yeah. And we have something similar right here. This is a val C equals whatever. And we have the same kind of logic here. Gross, gross, gross. Okay, so match solutions plus unmatched solutions. And this will be our continue. So, well, that equals option dot when condition that starts with a question mark. And in that case, it's conditions that drop 1. Oh, and you know what? You also have to pass the contiguous damaged because that's where we're continuing from. So this continue up here. I hate this so much. I hate this so much. Okay, so an option tuple parameters continue with. So we have continue dot hold So if there's nothing, we C2. Otherwise, what's this autocomplete? It's probably correct. Nope, 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 that's not correct. So we have continue, and then we have then continue, and then continue, and then continue. Right. Yeesh. Okay. Similar code here. Now we can fix this down here. What was our option? We were writing option not when. And then we have contiguous damage. And that is this continuation here. Otherwise, it's 0. All right. Cool. So now we can just do match solutions. And we pass along this continuation. We pass along that continue. And then we're going to pass along our counted to every recursive call. And we don't assign that to a val. Okay. Well, now that can be tail rec. This, we need to pass along the continue, pass along the counted. Oh, okay, continue can actually be a list. Oh, geez, why didn't I think of that? This is getting hairy. Yeah, yeah, well, my recursive function goes for the 16K, but not the 150K. So it struggles with that. Okay, continue counted. Here, continue actually needs to be a list. And if we are folding, can't be tail recursive if we're folding, can it? I mean, what we could do is something like this. If continue dot is empty, then C2. I think I should use the if else instead of the fold so I can make it tail recursive. Else this cont this here equals continue dot head. And then this becomes continue dot tail. And we add the count so far here, C2. The very gross function to make tail recursive, but I kind of walked myself into this, didn't I? Okay. So we have similar logic down here. Okay, we pass along continue.tail. And what are my count solution calls? So this passes along the same continue. Cool. And this here, we have this cont, which needs to be just cons on to continue. Not an option. Oh yeah. We're gonna to list it. To list prepend that list of one element. Oh, hold on. This isn't quite what I want. Um, so this thing here, rather, this thing gets cause on to continue, right? Let's turn this into an if else. If conditions that starts with a question mark, um, then if we do this stuff here, otherwise it's just plain old continue. Yeah, that works. That's the extra thing added onto it. Okay, so now that is tail recursive. Um, oh, and again, because this is a worksheet, I need to put this to an object to make it tail recursive. So we indent that out, object foo, whatever. And then at annotation dot tail rec def. Okay, so that compiles. It looks like there might be some errors here. Dot um, dot. Okay, so we're having issues here. Not found count solutions. Wait, what? Oh, right. This needs to be capitalized. Okay, so is that now compiling? First input. Oh, okay. Well, there are now more elements to a tuple. Um, we can partially apply this. Right. Let's do none, none, or this is nil rather. Okay, you know what we're gonna do? We're not gonna rely on these tests anymore. We're just gonna see if it works for ANDS one. This isn't gonna be count solutions that tupled exactly. So we're gonna map and then we have conditions contiguous damage. And then we have default values of nil and none. And let's see if ANDS one still works. There's a not in tail call position. Okay, right here is not in tail call. Solutions that doesn't need to be tupled. Okay, there's another place where it doesn't need to be tupled. Okay, that compiles now. We're compiling, and we get an answer for one. Um, oh, wait, we have to actually do something with this. We take the sum of all of this. Okay, and I'm not going to do the same thing anymore. Let's do like a for each print line. For each print line. And 0, 0, 1, 0, 0, 10. Okay, we're not getting the same answers anymore. Oh, you know what we could do to make this old code work? We can, now we can get its default arguments. So equals nil, equals none. Let's see if that works. So if we're to say uncomment this here, right? Yeah, okay. Let's see. Def count solutions is going to defer. So we're not going to have all these parameters. Food.count solutions. There we go. Okay, this will work for us. And this can be as a tuple, sure. Args is a tuple of string and T is damaged. Okay, now this can work again. And it doesn't even need to be tupled anymore. So our tests are back up and they should be failing. They're compiling, they should be failing. Wait, do we have, oh, I hadn't even written those defaults properly. So I have no way of knowing if they were actually compiling properly or not. But I mean, I don't need the defaults anymore. So let's remove those. Default parameters. I'm not a big fan of them. It's easy to make mistakes. I use them very sparingly. Okay. Now let's actually try to debug and see what we ruined while turning this tail recursive. Only need to take d+1 elements. Well, okay, the code that really changed is here. Right? Like, what did this look like before? What was that? So if match starts with this, and we do recurse, continue with the previous continue. This is the only case. So counted gets passed on in all cases, that's fine. This can't. So if condition starts with a question mark, and it's possible to just drop that, and we drop that, and we add that to our list of things to continue on. Right? Otherwise, we just keep our normal list of things to continue on, and that's what we end up passing here. Count solutions on match.drop 1, assuming that you can drop 1, which that's the case here. maybe here in the end, when I actually get some sort of answer, if we get like a zero, a dead end here, like what happens? Because we still have a bunch of counted. Yeah, I mean, I think we have to do counted. Counted, dot fold, zero. Or, you know, we just do it like a get or else. Get or else zero, right? Maybe we do that instead of just returning a zero. And then, of course, in this case, we do consider counted because we would add it to whatever that C is. And we pass that on C2, some C2 in our count solutions. If we're counting more solutions, right? Some C2. Okay. That is better. We are failing for input 1. Take a look at input 1. But it's working for everything else there. Oh, and we're failing for stuff down here. Well, we'll figure out why. So this is 113. This is 4 different solutions. And I'm getting just one solution for this. Okay, this is one. We're just printing the arguments can help me debug. So let's do that. You counted. Great. Let's see what happens as we try to work with that input. Okay, we have an ongoing some sort. Oh wait. There are other cases where we return something, right? Okay, when we return Chris, we add the counted. Okay, if whoops. Okay, here we add the counted. We are adding the counted everywhere, yes. Counted. We're adding that there in the if case and in the else case for the okay, counted is coming up here. Yeah, we are using counted in each of those cases. Yeah, let's look at this more carefully. So we start with this list 113, and it starts with a dot. So only option is to recurse here. Like, I mean, this is like a performance optimization we could do, right? Like, just strip all the dots from the start. And, you know, like pass along all of the parameters. That doesn't change anything. So any like strings of dots. In fact, like we could do pre-processing to the whole set and just remove all strings of dots and replace it with one, right? So that works. Oh, what I do? We were looking at this. Oh, that's right here. So this makes sense. We still have a count of none, but we have a potential continuation. And the reason we do is that we consumed this. Yeah, right. Basically put one and then nothing. And our continuations have the remaining question mark with 113. That makes sense. Okay. And then of course nothing changes while we're removing just dots. Here we have the next set of question marks. And now we add a new case here, right? So the second question mark here, the second question mark from um, the second question mark from the second set, the second question mark from the first set with 1, 3 and 1, 1, 3, but just 3 left to match, right? So we keep uh, going back down, dropping stuff until we hit this question mark dot dot. And at this point, we have the 3, we can match that. So we're going to match that. And now we have an empty string, empty list. We matched that, but we didn't add to the count. Oh, wait, this is where we add to the count, right? Okay, sum 1. And it appears we did not continue because we still have these other cases to handle, right? There's this dot. Why would it drop? Why would it drop that as an option? Okay, so when you have an empty string, oh, and by the way, I just noticed, it could also end with like an empty line altogether. So note to myself here, it doesn't necessarily have to be followed by a dot or question mark, the group that you're matching. It can also be followed by nothing at all, as long as the thing that follows it is not a damaged piece. So we need to change our condition there because that is probably a bug that's not caught by the test, but will be caught by the data. Maybe it didn't catch it for part 1. Okay, so we get to this point and we still have more stuff to handle. And like, do we not handle it? Why is your next call here? Oh, right. It's this thing, right? It's trying to handle this thing. And after it handled this thing and decided, oh, we can't do anything about that, it did not continue. Which odd that decided like that was a thing to handle, maybe. Okay, but after this point, we returned something prematurely. We have a string, we have a 3 that we can't match against it. Okay, let's look for that kind of case. So it's not nil, there's not an empty string, right? So we're down here somewhere. If matchable.size is less than d, that's this right up here. If condition.head option not for all contains, what is this saying? I should really replace this with like named conditions, right? If head is potentially like something we could choose not to match, that's not actually the case here. Ah, this counted.getterElse. It's not that straightforward. First we look at continue. So if continue dot is empty, then counted.getterElse. Otherwise, we do this stuff. We take the head of continue, and we have continue.tail passed on. That is it right there. That is our bug. And we have a similar thing here in this other counted.getterElse. Just indent that properly. Okay. And does that fix that for all the part one things? It appears no. Well, was there a change? Is this now working here that where it wasn't before? Let's take a look at this again. We're still getting the same thing, which is that we're stopping here. We're returning that one, but we should only do that if continue is empty, right? Like where are we using counted? Um, I mean, here we are looking, every time we use counted, we should first look at continued. Here's one. Oh wait, no. If continue is empty, right. Otherwise, we take stuff from continue. Um, yeah, everywhere we're using counted. How about here? We're not using counted, we're just passing it along with more continue. Here, yeah, we're just passing counted along. Hmm. Curious that this didn't change. Let me just like is my worksheet like reprocessing things? That's it. My worksheet's not reprocessing things because where's the 2 plus 1 in there? Let's see. I mean, it says last it checked, it was able to. Maybe I had an out of memory error that killed everything. Let me just try again. 2 plus 2. And yeah. I'm just gonna restart. Okay, so we are close. Um, just a recap. We've got this ugly, very nested if else condition checking. Made uglier by the fact that I needed to make it tail recursive so that we wouldn't run into performance issues. So all my continuations get placed here, right? And then everything I've counted so far is placed here in this counted variable. Oh, it is processing something, and it seems to be struggling with it. Okay, so my latest iteration, oh, I mean, this is uncommented. Let's see if we at least are still getting correct answers. I hope it gave up on that. Yeah, out of memory error. Okay, so it's getting correct answers. It's just not performant enough, but I have ideas to make things more performant. So last I checked, we could handle all of these, just not this 150,000 case. So let's check on that. And we can do some pre-processing wherein we take big lists of periods, for example, or we could just sneak that into the top here, right? If conditions that starts with, if it starts with a dot at all, this is an else if. So undamaged. So there's undamaged unknown equals dot contains. Or actually, you know what? There's like a strip prefix function, right? So conditions that strip leading. One of these needs like a prefix. that only gives a fixed string, so you can't like drop all of them. What we'll do is conditions that drop while. Yeah, and then we'll pass that into a recursive call. So we're going to count solutions. Count solutions. And conditions that drop while here. So that's like one simple performance improvement. We see multiple of these, we can just drop all of them. And what's another one here? If matchable size is less than D, then we only continue if it starts with a question mark. Conditions at head option. Wait, matchable nut size is less than. Yeah. Then recurse if it starts with a question mark. Why is it or starts with a period? I don't think that makes a difference, that period. Basically, if condition starts with a question mark, then we can drop one. Right, because the matchable bits are damaged or question mark. Yeah, conditions drop one. That's not really like a huge performance improvement, but otherwise we try to we're still getting correct answers for all the part one things. Part two, did this even run properly? Okay. Let's see if this is trying to run this. We want to be pretty conservative about like when we run things. I wonder. I was gonna say, I wonder if like it's gonna be some sort of factor of the previous one. Like we shouldn't actually construct all of this. Oh, Alka, thank you for the raid. You gave up on part one. Oh no. Well, I got part one. But the problem with my part one is I use a recursive function. And to make it performant for part two, I have to turn it tail recursive. Well, I did turn it tail recursive. And iron out bugs. And it's looking like it might still not be performant enough. So I'm doing more performance optimizations right now. Lollylol, welcome. Welcome to the chat. Yeah. So that's what we're doing right now. And I'm seeing what it runs on. So it can handle these examples. I'm about to uncomment this line, see if we can handle that. Hold up, are we wasting time doing recursion instead of sliding window? Yes, we are wasting time doing recursion. I mean, this is essentially like a recursive sliding window. I keep moving it forward. But like I wrote it that way to start, and I was like, oh, I don't want to rewrite. And then I decided, okay, well, let's just fine tune it, make it tail recursive, and see if that works. And okay, so that works for 2500. Right. Wait, how long did it take that to run? Did it take that? Okay, yeah, in less than a second. Does it work for this? And like I doubt it works for this. I mean, this might be a point, and especially now that there are new people here, maybe I write a new approach here altogether. And I've learned some of the ins and outs of what like what the specifics of the problem are. What some fine tuning we can do is, oh, I think this is enough to bring it to its knees. By the way, sweet radish, have you finished? Um, we're gonna save this as like part two and kind of start over. And in my day 12 worksheet, I'll just comment stuff up that's not gonna run. There we go. That runs no problem. I think this is problematic. Oh wait, that's the biggest one. Oh no, that's not the biggest one. Okay. We can take back some of this. Oh wait, it's all gonna be here. So I think I still want to have this test code, certainly. We're gonna have a parse two, we're gonna have a parse one, and our count solutions function, we're gonna do this a little bit differently. Let's take out this monstrosity. We can reference it in the other file if we need to think about logic. All right, and now let's match things one at a time. So let's say we have, we're gonna do it this way. So let's say we have, a single integer we're trying to match, right? And we're trying to match it against a string. Um, in fact, let's turn that into helper function. That way it'll be more testable. So def, uh, let's say like matches. We could get like a list of matches given a condition string. Still using strings. I opted not to parse anything. And to match. So you have a contiguous, or let's say damaged it. And then we're gonna have like a list of potential strings that can be remaining after such a match. What's the issue with this here? Oh, right, it just doesn't like that. I'm starting a new def. Okay. So we're gonna strip off any dots in the start. So if conditions that starts with that requires a string, right? If it starts with a dot, then we're gonna do conditions dot drop. We're gonna call matches on conditions dot drop while it's a dot, and pass over the same damaged. So we're just gonna gate everything by that. And now we're gonna try to take damaged. So val match unmatched equals conditions that split at damaged. Yeah. And And what do we have now? So if it's unmatched needs to not start with. So if um, rather like, so as long as we can return unmatched as long as it starts with or drop. Yeah, we can return unmatched as long as it starts with or doesn't start with a damaged piece. If not unmatched, that starts with damaged. Or rather, if unmatched starts with damage, then nil. I suppose there are multiple places where we can get a match, right? So we can calculate all of those. So all the matchable locations are um, well, we could take the full string. So we could take the full leading string that has either question marks or damaged pieces. Right, so the whole matchable area. This is sounding familiar. So matchable, and for each of those matchable areas, you get a potential string that we return. Interestingly, it's taking my code from the other file. Okay, so now we can slide our matches, our four, right? So we take all the matchable stuff, we check. So let's say damaged. For each of those, we need to check that the piece afterwards is not the potential matches. Um, First, let's check if matchable is large enough, right? And just gate that. Like maybe our code here would catch that, but we're not sure yet. And we'll return all of these potential strings, and then we try to find matches on those. And we will do this like iteratively instead of recursively. So calls to matches will work iteratively. Um, okay. So we can drop 4. We can drop up to damaged minus or matchable dot size. Matchable dot size minus damage. So we're gonna take that many. And we don't quite just want a slidable on conditions, right? We want this is what you want. So you want conditions dot tails. And from this, we're going to drop all the tails that won't be large enough. And we'll have to like zip this with like the remaining whatever. I think there's a way to get both the pre and post. Oh, this is what we're gonna do. So we're gonna match the. How about this? For a range of numbers, we split the string at that number, right? And then we'll filter that list. Drop the ones at the start of the list where it's too small, the matchable size, and then we have to zip that with the tail of the list because we still have to check if like the element afterwards. I mean that doesn't necessarily have to be a list of 2 strings. We can just get that character. Mm, I prefer doing kind of a drop approach because then I won't accidentally like index out of the list, so I won't get just a character. Like this should be, I think this should be performant enough if I use this properly. So we're gonna take for I from 0 to matchable dot sized minus damaged. It knows. So this isn't exactly what I want to do. We want like we want a yield, and we're gonna do like a matchable dot split. Oh, lucky boy, thank you for the follow. So we're gonna split at that I, and we're gonna do like damaged. So I damage is the minimum, and the maximum. So let's say matchable size is 10 minus damage. Um, Maximum split then is what's that gonna be at 6? Let me draw this out. So we have x, and let's say we have 6 remaining, right? And then we could take that all the way to like drop, 4, 5, 6, and then x. So this is an I of 0, and then this after 6 elements. So 0, 1, 2, 3, yeah, this can be 6. Which for matchable size was 10 minus damaged 4. Yeah, that's exactly what you want. Um, oh, but we can't necessarily drop. So we need to make sure that whatever we're matching, the portion before the match is question marks, right? So we're gonna have like a few checks in here. Why don't we put this in and we'll add some checks here. So if, oh, it knows what I want to do. So if matchable.take I, this is how much we're skipping. Well, not quite I. I minus damaged, right? Okay, yeah. Or all contains a question mark or a dot. Like there shouldn't actually be a dot because this is matchable. Um, no, it can only contain question marks. Because if it's a damaged piece, then we have to start there, right? So actually, there is a first and a final location where we can start this, and it depends on like the contiguous block of dots or not of dots of damaged pieces, right? So if we had this, right, if it started with an X or with a damaged piece, then we have to start right here, um, no matter what. So that is one of our starting indices. If we have a question mark, we can drop as many like question marks as we want. But the moment we see our first damaged piece, then that is our last location. So the first index of, yeah. Um, so what is a matchable index? Start at the first question mark. So this is a whole kind of matchable area. Presumably this unmatched is going to have everything else. What are the subproblems here? The subproblem I'm working on right now is just finding the indices that I'm allowed to start my match at, right? So obviously it can start at the beginning. Let's do this. Val match start, and this is going to be matchable. We're gonna have those indices, and we're gonna do a take while. Let's skip the index of the first blank. So val first damaged, right? And then we have that until we basically have 0 until then. And then these will determine our strings, right? As as long as it stays within range. Like, so what is our maximum damageable area? It's going to be matchable.size minus damaged. So for 0, or I from 0 until matchable.size minus damage plus 1, the min of that, the min of first damaged, I'm gonna do 2. So 2 first damaged dot min val last potential start. I'll just be very explicit about what this is. So matchable.size minus damaged. Okay, min last potential. And for each of those, we return, we drop that mini and then drop 4 from the string. So we yield, and this whole thing will become a list. Or, you know, let's just give, we're gonna take this, we're gonna turn it into a list. We're gonna take our I, and now we're gonna take conditions dot drop I dot drop damaged. Right. And now this whole thing is testable. So let's give it some tests. So matches. Let's say you know, dot 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 dot. Keep this very simple. There should only be one match there, or 0 matches there rather. We don't start to get more until we have question marks. So here, oh, what's not running? That's a foo somewhere. Take that out. We don't need any of these running right now. I'm going to comment them all out. Okay. Right, okay, so there's only one possible list. Now, let's say we have a question mark. There should still only be one possible list, and it's one that starts with a question mark. I think I want to truncate. I want to drop that first element. Um, if it exists, right? Because like in this case here, you won't be able to drop a first element. In this case here, where there are not any undamaged pieces afterwards, right? Oh yeah, like this. This right here is wrong. Um, but we can try a few other things. So if it starts with a question mark, then now we should have two options, right? Yeah, that's the first case where we have two options. And, if it starts with a dot, that should change nothing. Um, yeah. And now if we add more question marks here, that should change nothing there. But if we move this damaged piece further, then that should start giving us more answers, more potential answers, right? Oh, you get more potential answers the further out that is. So I'm liking most of this here. We just have this edge case here where it matches exactly. So unmatched. Um, and look, ma, no more recursion. Okay, so matchable.index. Conditions that drop. Oh wait, this is a list. This is fine. Okay, look at the size of this. It's a list of empty string. Okay, yeah. I'm happy with this. I'm happy with this. So now we can just do this recursively. Um, oh, we do want to do a drop one on whatever that answer is. That drop damaged dot drop one because it's going to need a buffer space of some sort. That's better, right? This is what should remain after each of those. And none of those are airing out. Now we can use that in a broader function that counts solutions. Okay, we've got this. We've got this. Pull up that code on the left. And now when we count solutions, oh, we can do this as a fold. So let's do, oh, we're still doing it that way. Okay. Well, we're just making it a little bit easier for myself. For some reason, I want to pass the parse in directly. And the parse tuple. Okay, so let's take contiguous damaged that fold left. And if it's 0, this is sort of where we start blowing up, right? Because for each of these potential, let's say this case here, right? There's three potential solutions. And we have to call on more matches on each of those. So we kind of have a state. We have like a growing list. We're kind of getting into the same idea here, but we want to keep it linear. Okay, so we're doing our fold left. We have our default of 0, and then that's being kind of accumulated. and we have damage. So, oh, okay, Sweet Radish, good luck, good luck. Have a good night. Thanks for stopping by. Um, Great. So we have an accumulator, we have whatever is damaged. The number damage. So we have this m dot size. That's not quite true. So like we have a growing list of strings to try this on. So let's say we have our first integer, right? This damaged here. We only have one set of conditions to try on it. Um, we have so we here have a list of conditions. And the problem is each of those lists of conditions will have um, I suppose a list of integers associated with it. Unless we keep this flat, right? We keep this flat. This is the list of conditions so far. So potential conditions. I think I'll just shadow it here. So we have counts. I don't think we even really need counts quite yet. Not until we reach the end. Basically, how many ways are there to get to an empty string is what we're asking, right? And what happens if we hit duplicates? If we hit duplicates, oh, you know what? There's potential for hitting a lot of duplicates, right? Let's say you have your first big group that has many different ways to match, and then a bunch of dots, and another big group that has many ways to match. They are all going to reach that second group eventually. So what you can do is split them. There are a few approaches to this, right? So we can memorize. We could memorize and recount. We could count how many ways there are to get to that state, and we can multiply. We can also, what's another approach here? We can also just split this up. Split our whole input up, our list of conditions, by all of the groups of dots. And I think that might be what we want to do. Not necessarily, right? Because there could be like two groups of question marks, and you could choose to handle any number of your integers in any of those groups, right? You could choose to ignore completely. Anyway, for now, we're not going to dedupe, but I'm keeping that in mind. Yeah. Maybe memo. Memo is the simplest one to implement, and that might be what I end up doing. We're not going to have counts. We're just going to have conditions after matching however many you have matched, right? And now we're going to take conditions dot flat map exactly Um, take these conditions. I'm just going to do like matches on them. And that becomes our list of conditions for the next bit. And what happens if there's nothing? It should just be like empty string, right? So we need a space of 2. Let me just comment this out for a second. Make sure I have that test in place and know what happens. And then like the list of this dot size should be 0. Okay, conditions, we flat map them. These all get passed along. And then in the end, we count all the conditions that have no more damaged pieces in them. Conditions, flat map. This is really all there is to it right here. And then we have like a final conditions. And then final conditions count. Yeah. Or or another way of saying this is not exists. We could say not that string contains any or we could say not contains the damaged piece. And now this would work. We're getting 0 for all of those. That's not that's not quite what I'd hoped for. Let's run through this bit by bit on one of these examples. So let's look at input 1. We're going to pull up the day 12 example. And are we operating on the example right now? We are operating on the example. So let's say matches question dot damage, and doing that with a 1. Interesting that that is the only option it sees. Okay, so that's a bug, right? This should give us 3 potential solutions. And let's look at why. Index of this, if it's -1, we don't have to worry about it. There might not be a first damaged. Okay, that we can handle. How do we do this? Index of I don't know. We'll just do if first damage is -1 or is greater than or yeah, greater than -1. Then we have this same old code. Else, and this could probably be heightened up, um, but that should work. Okay, there are three potential solutions here. Right, right, that's good. And now, let's see what we get here. 0. Now, input 2. Input 2 is problematic. Interesting. So that starts with a 1. 1, 3, 1, 6. Let's try that. Matches question, pound, question, pound, question, pound. And the 1. What can we do? Yes, there are only really two options. Getting two options. Let's break this down a little bit. Question, pound, question, pound. Okay, there's one option where basically we match here. And apparently there is a potential option where we match here. There should be exactly one solution here. In fact, we can find a simpler error case, right? Like this should not be a thing. There's only one solution here. There's only one solution here. If we look at this dot size, yeah, that's too big. Let's look at this. This here works properly. So yeah, since that's working, let's put that above. And now this here is what we need to fix. Keep an eye on that. And what was it? It was question mark and pound. Um, yeah, so we need to filter out. Make sure whatever comes after it, whatever comes after it is not damaged. So I did talk about doing that earlier, and then I sort of forgot to add it back in. So we need to filter these further. What we could do is filter out. Dot filter starts with damage, right? We can't have it starting with damage. Starts with is not a member of character. Oh, okay, right. It's whatever's in this map that we're filtering. Not filter starts with damage. Or filter not, rather. Okay, is that valid syntax? Cool. Yeah, we do the same thing here. Yeah, this works. We can condense that later. We're still getting good answers for this. Oh, we're only getting... Okay, we're doing that filter too early, before the drop 1. So, dot map, dot drop 1. Okay, and same logic here. At some point, in fact, right now, that we don't have to keep editing two things. Val what are these indices? I'll just call them indices equals, and then if first damage, it knows exactly the refactor I want to do. Right. And then now we just take indices, and we can just do the map, right? Um, okay, drop that many, and then we drop damage afterwards. Filter not starts with damage, and then drop one. And then what, a 2 list at the end. Okay, so that works. This is back to working correctly here. This is back to working correctly. I mean, it was never working correctly. It's now working correctly. And let's see, if we add more stuff, it should still have just one solution. Yep. Yep. And if we add as many as we want, there we go. There we go. Very nice. So we've handled that. Now input 4 is problematic. Others seem fine. What's going on with input 4? So let's take a look at that up here. And let's look at the solution it's returning, right? Most of it matches. So 4 question marks. And we have 165. Question mark, question mark, question mark, question mark, dot, pound. Nothing else should matter there. And then 1. So how many ways are there to match 1? There are 1, 2, 3, 4. Right, we found all 4 ways of matching that. Interesting. And then the remaining stuff, right, any of those remaining, the val, foos, the foos. For each of these, there should only be one match. If we match just one element, so foos.map matches with just the one remaining pound. And then, I mean, let's see what we get. We get a list of 4. 1, 2, 3, 4 possibilities. Or, I mean, I guess we could flat map this, but yeah, each of those has size 1. Not for all. Actually, let's do this in another line. Not for all. That size equals 1. That should be true. Oh, some of those are larger. Ah, that first one has multiple. Okay, so this one here. How could there be multiple? So let's look at that case. Matches, question mark, question mark, question mark, dot, pound, with just 1. And it gives me 2 solutions when there should be just 1. And the problem is trying to match. Yeah, it is trying to match in there. I mean, okay, yeah, that's actually fair. That's fair. That's a fair answer. That's completely appropriate. Were this instead, you know, 1, 2, 3, 4, 5, then now when we do this, there should be only one way to match a 5 for each of those. Interesting. So all of these remaining, all of those have space for a 5. 1, 2, 3, 4. Some of those are empty. Okay. Dot map s to s and s dot size. Sure. And then we'll do a for each print line. Examine that a bit. So the first two have no solutions. We can look into that. So matches question mark dot 1, 2, 3, 4, 5. And we're trying to match that 5 right there. Whoop. This should be size equals 1. Okay, so if there are, right, so if there are no matches, it should be willing to drop question marks from the start. That's kind of a condition we've lost since the other one. Hmm. Okay. So if matchable.size is less damaged than nil, it's actually not completely true here, this nil. So if matchable is all question marks, right? Like we have, where is it here? Matchable is all question marks, then we have a second life. If matchable dot for all, or yeah, matchable dot distinct equals question mark. So if we get just a question mark, then we take the matches of unmatched. And I don't think we need to drop 1. Well, I guess we don't need to drop 1. Like we might be able to drop 1. Otherwise, then it's nil. Okay, so that should fix that case. Yeah, there's now 1 case here. And this, that's all 1s. And this, it works. Great, great, great. Now we have a parse 2. Yeah, we have a parse 2. And let's start testing these. Okay, it's off on this input. Worth looking into. But how's our performance? Look at all those. So most of those are working. Oh, and they're working like fairly instantly. So our performance is a lot better. We just need to fix some of our accuracy. So let's do a parse 2 on input 1. And actually, what is input 1? Input 1. Okay, right, it's this. And you have 113. And it's going to be 4 times 4 times 4. Oh, it's like 4 to the 10th power. Is that 4 to the 10th power? 4 to the 10th. 16, no. 16384. 16384 is something. I'm not sure what something it is right now. Okay, what's the actual answer we're getting for this? We're getting only 64 possible solutions. And it's 1, 1, 3. The 3s will always have to be here, right? So 2 choices for where to put that 1, 2 choices for where to put that 1. It's 2 to the 1, 2. I mean, there are 10 of those groups, right? So this should be 2 to the 10th. 16384. Let's look at that. 16384. Okay. Okay, well, let's do this with smaller examples. So matches, well, accounting solutions for that works. Let's do this. We'll do account solutions, and the list is 113. Question dot, question dot, question pound pound. In fact, we'll simplify it even a little bit. We'll do that. Right, there's one solution for that. And now if it's 113 again, so just one repetition, dot question dot, pound pound pound. There should be only one solution there too. And now when we start multiplying this, so this, there are two options for each of those ones. Multiplies by 2, multiplies by 2, multiply by 2, and a multiply by 2. I mean, for two repetitions, this is working properly, right? I mean, let's turn one piece into a question mark here. And actually, this parse to bit, is it just the same thing repeating? It's not just the same thing repeating, is it? Because there's a question mark between these. Yeah, there's a single question mark location here. That's where the extra variable is coming from. Okay, so let's do that. Extra question mark. Interestingly, now we have fewer options, right? If there are a dot at 16, here it is fewer options. Interesting. So if we can minimize that case, let's try and minimize that case. Because now you still have 113, right? That still needs to be the first 113. What if we just remove all of this leading stuff up until the first three? Now we just have this 113. But now there's that leading question mark. It thinks there's only two solutions for this, which is false. So here we've sort of minimized this case. Let's see if we can find something even smaller, right? And I think I'm starting to get an idea of what this is. Let's say it's just 1-3. Yeah, there are actually three options here. Let's say there's just two options right there. That should be two. Yep. So what it is in the case when there is a question mark group, we're failing to look at the possibility that that question mark group is not matched at all, right? And it's similar to the one we did an if else for. It's similar to this one here. This isn't exactly a recursive call, but we're starting to get there. So here, even if that's the case, we do have the option to drop. So this happens regardless. And this is where we start to turn into a function that needs tail recursion, except this isn't handling the whole thing anymore. This is handling a much smaller part of the problem. So it's okay for this not to be tail recursive. Yes, this happens. This check here happens um, regardless of this size damage thing. This is really only a check on this. So just up here. Now, next match. Um, right, and we can just cons that. And what can we call this bit here? Val. First match. Sure. And then we just concatenate those two. Next match and first match. Okay. And like we hope that doesn't blow up, right? Okay, we're starting to get proper answers now. This here works again. Okay, nothing's blown up yet. Now we just have one final case. Fix. And it says input 5. Let's take a look at that. So input 5. We're very wrong on that. Oh boy. Yeah, okay, big string of question marks. Okay, and like we saw this properly for the first case, right? Uh, we can count solutions. And what is this 3, 2, 1? So question mark, pound, pound, pound. 1, 2, 3, 4, 5, 6, 7, 8. We're going to take this and we're going to minimize it. But for now, let's copy it. List 3, 2, 1. Right? Like this should be 10. No? If I wrote it right, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then now what happens when we duplicate it just once? So we have a question mark. The longest time I was just appending the given things 5 times without joining the question mark in between. Yeah, that would be a pain to debug. I know reading is such a pain in Advent code. It's a delicate balance for sure. Okay. The count solutions here, list 3, 2, 1, and then we have 3, 2, 1. Right, I don't know how many more solutions that should be. Yikes. Let's make this something a little bit more manageable. So there's a 3. And then there's a group of 2. Let's give it 2 places to hide. Question mark. And we'll just remove the 1. And this is just long groups of question marks. Oh, could it be? No, we're not overflowing. But could we overflow at a later time? I don't know. I don't know yet. Okay. So let's change this to 3, 2, 3, 2. Right, there's still a group of 3, which can only ever be here. It's separating those. So here there are 2 places for that to hide. Let's add that question mark. And then 1, 2, 3, 4 at the end. So 2 places at the end for the second 2. and then still 2 places at the beginning, so this should be 4, right? Um, yeah, and that's correct. Why do we start having issues once it repeats itself 5 times? And, like, what are we getting here? 5,600, 500, 6,000. Why are we exactly 1 million off? What's going on there? Isn't that weird? That feels like a coincidence. That feels like, oh, okay. Yeah, there's just no 1 there. It was correct. It was already correct. There's nothing to debug. Nothing to see here. Okay. Yeah, exactly 1 million off. Sheesh. Okay, well, I mean, we have it then. So what's ans 2? So input dot map parse 2 map count solutions dot tupled and dot sum. Just count solutions. There we go. 525152. I wonder how long I had this answer. 525152. Okay, your answer is too low. So we can binary search it. 525152. 525152. Okay, that is what I submitted. That's why. It's because I was still on the example. Okay, let it run for this. Oh, and now it might blow up. Oh, and now there's too many test cases. Okay, but 525152, right? Like we're back to working again for part 2. I mean, weren't we working for part 2? Yeah, we'd already gotten this to work for the example for part 2. The only problem was that we were getting like a Stack Overflow. We can make this more efficient. Here, I think it's a lot less likely that we'll get a Stack Overflow, right? Unless there's like a monster super question mark, question mark, question mark, where like you're mashing a 1 into there, which like that very well could be the case. Then like this one here could end up, oh yes, as I consider memoizing, because there'll be a lot of cases that are the same. And as also considering splitting strings on dots, right? Wherever a dot is, then running my matches on each of those, right? I think that's an important insight for performance optimizing this, and one that I could implement easily. But see, the problem here is this is running, and I'm like, what if I just wait for it? Like, what? Oh, wait. Now it's running multiple. Is it running multiple worksheets now? That's no good. Because it was running that. It had something going on in the background. Wait, or did it finish? No. What happened was, yeah, we ran out of memory before we even got to whatever. Okay, we stopped that. We stopped all of this. We switched it back to the example quickly before it keeps running. So this I'm happy with. I am going to, maybe I'll leave my test for now until until I'm finally ready to run, and that will be after I've done some performance tuning by splitting on the periods. So day 12. Let's look at a day 12 text. Right, there are a lot of these that are gonna So, okay, maybe maybe it might not be the case that doing the dot, um, splitting on the dot helps us because like this here, there's no splitting on any dots. It's gonna be like repeated 5 times over. Gonna be repeated 5 times over, and then like more question marks added in between. Um, so like this is a problem here. Big groups of question marks should just be solved with math. It should be solved with combinatorics, right? Especially like, look at this. So we have a bunch of ones. This is basically just like this is a partition problem. Okay, let's dwell on that thought. I need to do that, so I'll be back. 50 seconds. Okay, fair enough. All right. So I have my insight, and I think I know what I want to do here. It was going to the bathroom cleared my mind. So we've handled the case where there are a lot of periods, right? Like that little optimization. We haven't handled, for example, a case where there are a bunch of these question marks. I think we should take stuff like this and be like, okay, so question mark group, how many ways are there to do a one in there? And then there are also like big groups of pound symbols. X proof, did you solve day 12? No, no. We are about to though. I mean, we need to performance optimize a solution here. Hmm. Um, so there's also like these blocks here, big blocks of damaged pieces. They can sometimes be helpful. I'm trying to look through this input in the example input. Does AOC have timeouts? No, no, no. There's no time limit. Like you could still solve problems from 2015 if you want. Oh, I see what you mean. Yeah, yeah. You could brute force this. You could let this run all night if you wanted, and then like submit it 20 hours later. But where's the fun in that? I'm just giving up. Um, okay, so like look at this example here. Right, there's this block of three, and this always has to be in there, right? So like that's gonna be broken into a subproblem where it's like we match a group of how many ways are there to put so and so many question marks in a whatever. um, right. So I think we start by writing a little helper function that counts the ways to just the question marks. And an issue that we have here in our matches method It's just we return the list of strings that could be remaining afterwards. And that's not really like that doesn't really work well with just a number being returned. Um, yeah, actually, here, let me just reset something real quick. Turn that off. Let's run what? Oh, yeah, 30 billion years. That's too long for me. Okay, we seem to have some errors that didn't exist before. I think this just has to do with like everything fritzing out because I like crashed the JVM that's running behind this. Um, so it's back to working on the example. We're just gonna restart Avena code, and then we start we start writing helper functions that count. And I mean to start turning this into subproblems, right? And we have our matches function here, which you know, it returns like all the remainder strings after a match. And then we have this count solutions, which is flat mapping across all of these. Oh, why is it running so long? Okay, that's fine. And the thing is, like these strings start out really long, right? They start out really long, and we don't even really need. We don't need that whole thing. Where was I going with that? Um, yeah, I want to break this down. I want to break this down into smaller problems in any way that I can. Right? Like one idea was splitting on these dots. Another idea was splitting on big groups of these that should be matched by like an integer that we know about. But like another reason is like we might see the same problem multiple times, but we might see it in different ways, right? So you might get like a string dot dot dot. I don't know, question question question, whatever, and then like we're matching a one in there, and we might like get the same thing again, right? So all of this, whatever. And it might be the case that like okay, this subproblem is going to be like the same as this one, and we only want to solve that one subproblem twice, or I mean, we only want to solve that once. But the first time it gets it, it's going to look like this. So in our count solutions, we need a way to split this up and be like, well, it's number of solutions for this part, and then a number of solutions for this part on the right hand side. Um, and like maybe we still memorize this. So here we are back to recursing. If matchable.distinct is question marks, then we skip ahead. into the unmatched part. Because you look at the case where like maybe we skip past all of those, maybe they're all undamaged, and that's the next match case. And this is the first match case where a matchable has to be matched somehow. Hmm. What if we look at a case where we start with a question mark, we have a group of question mark. Um, well, I mean that's exactly this case here, right? And then we have to add that to other things. I wonder if we had on conditions like a flat map splitting that happens not in this matches method, but outside of it. So like the string, whatever question mark, gets turned into two potential strings. And for each of these strings, we try to match at the start, right? Well, hold on, question mark and a dot, right? So this gets turned into two strings, one that just starts with that, and we try to match just that first part. I mean, that's the same as splitting the inputs on just periods altogether. So we can do some pre-processing. It would simplify this somewhat. All right, then in discount solutions, how would that look? Conditions are now lists of strings. Then one of our conditions might be a list, right? For every condition that starts with a question mark, we potentially drop all of those. Yeah, let's see what that looks like. So, um, a test string val foo question mark dot question mark, and if you have two such strings, um, or rather, I mean, I guess these are lists now, right? Suppose we did split on strings, and instead of conditions is now a list of string. And now we get like a list of lists of strings. And then we have to be careful about how we nest those. Def groups. So we have a condition string. And we have a bunch of groups to handle. And then we take conditions that's split on dot star not less. Before we do any of that, like we trim all the leading dots, or we just filter empty. So we split on this dot. We need to match that. This is a regex. Not filter not is empty. It's blank. This blank is a method on. Oh, okay. That includes white spaces, but we're only worried about is empty really, because there are no spaces here at all. Um, yeah. Okay, so that gets us our groups. And now if we're operating on groups, this operate on matches should operate on a single group, right? Like this here is a way of skipping ahead to the next group, and we won't need that. Um, yeah, we're just matching the first now. And then we potentially like drop a group. So now suppose we had this foo, and now we can potentially skip any number of groups of those. So what's wrong here? Turn this back to a list. Okay, so groups from foo. And I suppose we have tails. And we start dropping elements of this. Like I determine like how many of these groups can we drop. Next brief, how much experience do you have with Java? Honestly, it's been a long time since I've occasionally had to write Java, but for the last decade, it's Scala is as close as I get to Java. Sometimes I write Kotlin. The Lombok library. Um, is that related to this problem? How spoilery is that? Lombok. Oh, Kotlin Lombok. This is already in my. Is this the one you're talking about? No, not that. Lombok, Java. It's a very contentious library in Java. Ooh, spicy. It might be good. Never write another getter or equals method again. Oh my god. Oh my god. This is a this is solving a problem that you could solve with language design. Yeah, I don't have to write getters and equals and all that boilerplate because I write Scala. They don't solve it using compiler hacks. How do they solve it? They solve it using compiler hacks and JDK internals. Yeah. I mean, that's the problem with working with Java. Even if you're not using Lombok, you might have like these crazy annotation preprocessors that are like so much harder to deal with than just a compiler. Um, like every big framework is like a bunch of hacks that work around like limitations that the language gives you and in really ugly ways. So I mean I would probably hate I don't know, I might hate Lombok if I was using Java if it's like hard to compiler hacks are tough to deal with sometimes. So I don't know. At least it's not annotations. Annotations are the worst and a big reason I hope never to do enterprise dev in Java. Um okay, so Tails, what am I doing here? I want to take all my I want to take a group of conditions and turn it into um, several groups of conditions that we first. I don't think we have to do it that way. So let's say we have our conditions grouped. we potentially match something against the first. I'm not sure. Like, I still kind of like this function here. Um, what if we write an alternative? It's like just matches first, right? Matches within that first block. The problem is like I don't like doing this thing here. This next. Did you say memo? I did say memo. I said maybe memo. And that only applies if I break this into smaller subproblems. Because we'll see a lot of the same subproblems, right? Um, the problem is like not all of these. Wait, what is it? Day 12, example 2023. Or no, just day 12.text 2023. Let's look at some of these. So some of these lines have no periods in them at all. Right? We kind of have this binding us to where like a 4 has to be here, but then you could have 4, 2. I guess this could be a 2, and then afterwards somewhere in the question marks is a 4. So nothing is holding us still here. I mean, there are the periods, right? So let's look at the ones that don't have periods. And whatever optimization we do, it has to handle these cases that don't have periods. So let's make sure we can solve those. Otherwise, this optimization might be premature because then it still can't handle like this, right? We want people to handle this. And like one way of handling this again is handling like groups of question marks. Like if you have a big group of question marks, can you very quickly count the number of ways to handle that? And this is part of why I was like thinking I was like splitting this into smaller groups again. Because again, like this doesn't return a number, right? This returns a list of follow-up strings, which maybe if I can get a number, then that can help me just determine all the follow-up strings. But big groups of question marks, I think, is what we have to handle first before even handling like splitting on periods. Let's look at our input. Okay, we can keep these tests. We're still sort of happy with these tests, but I'll move them all further down. Yeah, like these tests I'm happy with like existing down here. These tests might need to be commented out. Um, Anything that uses that input. So like these, we're gonna comment these out. And we're gonna comment these tests out. To put everything, all the tests, they can all go at the bottom of the file. And this group method, I don't know, might still come in handy. This 4, we don't want to handle that anymore. I think this more tests I can just move down. Okay. Probably not need that right away. Okay, let's look at our input for day 12. And input dot filter. We want all these lines um, that don't contain a dot. Wait, what's evaluating? There's nothing to evaluate. Oh no, oh no, ans2 is not uncommented. Okay, save that, cancel this, cancel that one. Delay that order. Okay, I'll cancel that one too. Make sure our worksheet is healthy. And then we'll do input.filter. I might have to just close that. You could consider subproblems where you solve a suffix of the string and the runs vector. I mean, that's exactly the sort of this thing I am considering, right? Like that suffix would be, like I was thinking about grouping them, for example, into splitting on the dots. How does Bill need to, sure, we'll import changes. And right now I'm doing, like, I have this subproblem here. Or like, again, like this is a string that's too big. I'm wanting something smaller, especially since like that will open up like memoization. But I'm doing that with just the one int. Why group? Just do n by m. N by m. Where like n is the size of a particular match. Oh, yeah, I sure. I've worried you're getting too much into spoiler territory. I think I see what you're saying. For each suffix of string, yeah, that would give me like that would give me be one way of getting like smaller strings, right? Just start with the suffix of it, and then solve that against my whatever. And then I can do that for all suffixes and see if there's like what's left over. Before I do that, like I do want to look at some of these question mark problems. So filter dot distinct or filter not distinct contains that really we need to do distinct. We just filter not contains period. Or rather, this needs to be character. But how many of these cases are there? There are 56 of these cases, and let's print line each of them. Oh, wait. Filter not contains a dot. There we go. Okay, there are 109 such cases. And if we look at some of these here, this 6.2, for example, is a very easy one. Some of these get a lot trickier. What's the trickiest one here that we want to be able to solve? I mean, like here's one. we should be able to solve like all question marks 1, 1. And this one we can just solve mathematically. And again, this is a case where memorization comes into play. Um, question matches. So like we have a question group of some length, right? And then damaged int. I guess a potential thing we could write. I'm gonna leave that as a triple question for now. And as you suggested, I'm gonna look into some suffixes here. Is damage fold left. So here we have an int n, and if we want to be able to memorize this, like each of these, for example, should already not start with any dots. So if we do like matches from the start, well, the thing is, let's get this. So like it could be something like a bunch of question marks and then whatever. And then there's a bunch of question marks. Oh, wait. You're saying suffixes. I was talking about prefixes. I was thinking about prefixes. Um, yeah, solving it from the end. Solving from the end gives me a lot more room, right? So we take like your last contiguous damage. I would have to rewrite my matches, and I remember. Oh, whoops! Like it took. Like I did a lot of debugging on this here. Yeah, suffixes, not prefixes. I like that idea. Um, so we take our last int, and we just try to match backwards until we have something that works. Yeah, you're right. Okay, it is the same. They're still matching one int. I mean, the thing is, okay, with suffixes you're taking longer and longer, whatever. With prefixes you're taking longer and longer prefixes. And the thing is, like, okay, like maybe we have. I'm just reasoning through this. Okay, yeah, yes, I'll like to see your solution too when I'm done with this. Um, okay, so like with prefixes, we might get something where we match first bit, right? But then we might also get a case where it's possible. Oh, let's go back up here. It's possible to like skip ahead, and if our prefix is too small, so let's say we're just matching 3, and that's our prefix, then we might miss out on something that could match later. So like how big do we get on prefixes? Right? Like if we go all the way, I suppose we could do I mean, okay, I'm thinking prefixes and grouping are kind of the same thing, right? The maximum I could take is, so if we're looking for 3, we take up until we see 3 whatever, right? That's the most we could do. And that's like the minimum problem we can solve. Um, so like the latest this can go is after a bunch of whatever question marks, etc. Um, the latest we could match, right? This here will bind us. This is the latest we can start, and we go until here. And this is a thing I'm already doing. I'm checking this, what is it here, in my possible indices. And then everything after that point doesn't matter. So if I want to be able to memorize this, I can just pre-process it to remove everything after that. It can't matter. And that is a subproblem I solve, right? And I solve that in a I have to keep track of what happened, what possibly stays afterwards. So question. We take max matchable. We can define a smaller function that gives us like our max matchable whatever string, and then we try to match all the way until there, and then we return the remainder strings. And then the remainder strings still have to get added to the rest. So I think I'll do that like inside a function that then dispatches to our modified matches. The def max matchable. So we split this. We have our conditions string, and then we have our damaged int. And depending on whether we, I think I want this to delegate to a different matching function into the memoized matching function, right? And this will return a list of remaining strings, right? So this just defers to this and takes on some of its work, making this memoizable. I'm gonna put it above here. Um, and then let's take conditions. I guess we could do this kind of filtering out here. Right? I'm gonna end up renaming this function, but here we go. We recursively call to itself with all that stripped out. Um, Otherwise, we go into here and we do this logic here. Um, like there's a potential case where there's nothing. But I think I'll leave it. What I might end up doing is taking this, keeping it sort of as it is, because all the logic being done here for like whatever's the max matchable, and then deferring to a memoizable match. Yeah, if memo matches. And now val match memo. And this takes a string and int to a list of string. And now here, if match memo contains key additions to damage, let me just return that. Otherwise, we want to update. Yeah, like this is actually a method I could call match memo dot get or else update. And let me actually, and then we do just the actual calculation part on its own, the calculation of strings, and that is what bit here. So here, I think we can keep this val first match. Now next match. I think we can keep this next match and first match, and this first match here. This is what ends up getting that here to the memorize thing. We're going to just comment that out for now. And then last potential, we take the matchable size. We just take the whole. Yeah, so instead of working with indices here, what we can do is get a string. That's inside that string. We'll like all of this. Could all of this be what we end up putting up there? No, because we still want to pass a string. Oh yeah, I mean, yeah, if we pass a string, then all of this is what will be passed on. So we're gonna take some amount of the conditions. We're not just gonna take damaged. We need the first damaged And we could take at most damaged after that, right? That's where we pass match memo to. What's going on with my key bindings? Oh no, something's gone wrong. Um, I'm in another mode. My key bindings are not working. Okay. Quick. None of my key bindings work. I don't know how to operate this. I think I accidentally entered evil mode. Oh, did I switch? I see. I switched away from Dvorak. That was very confusing for a second. Okay. Um, where were we? Yeah, we're about to patch stuff over to our menu matches function. And what we're going to take is conditions that take first damaged, less damaged. And that should be enough. Like I think we could do like a -1. Yeah. And this is what gets passed to memo matches. So memo matches. Then we pass damage as well. Okay. And then now this stuff sort of just gets copied in, and then we will think about how that can be simplified. What's in here? And this is a map, conditions that drop, whatever. This is our, let's call that a cutoff. So, well, cutoff equals whatever this thing here is. The conditions that take the cutoff. And then we map that. So we add back for each of these strings plus um, conditions dot drop cutoff. And we can call that remainder value. I'm not recalculating that. Okay. And this matchable, we're always assuming it's matchable. We do conditions that index of whatever. I'm actually wondering if I shouldn't leave extra breathing room. I'm gonna leave some extra breathing room here, or for the element after what gets matched, because you want to check that that is not a pound, right? And here, okay, this is the same code. Maybe conditions that drop whatever, drop damaged. Yeah, like maybe this can be simplified, um, but I don't think it necessarily needs to. We get most of the benefits already. Okay, so this should continue to work, but now it works with a memo. And what are we testing this on? This is the full input. There were some particularly troublesome lines. I mean, we solved part one before. Let's just solve part one. Make sure we can still solve part one. If that works, then let's go for part two. 2381. Is that what I'd gotten previously? Um, 7916. That's not even the same answer anymore. Hmm. Okay. Back to the test data. I don't know what I changed to make that not work. Oh, we're getting like 0 for all of these. Okay, let's look at what matches does not work for. All that we've changed here is now we're deferring to something that memoizes, right? And I didn't change anything anywhere else. Yeah. Or if they just return list of strings, like perhaps you could return list of like an index, like this is how far in we were, and this is what we're going to drop. That'll be much smaller to keep in memory, right? We don't want to end up with a like add a heap space. But first let's fix some bugs. We should get one. No. There's 3 ways to match one in there. Um, okay, we're looking at where we might have changed things. We do have a map in here, right? Like we passed just the cutoff bit so that that can be memoized. Um, yeah, and then we take. I think what it should return instead. It should return a list of int for how much to take off. I think all of this should do that. Right? Like a list of int of how much to lop off the string. Especially, I don't know. That's what we're memoizing. And then we'll do something with that. I don't know why I'm optimizing right now before making sure my code still works, but that is what we're doing. So map conditions.drop. No, that's not necessary anymore. Um, we will keep these indices. So we're doing a filter instead. Indices, not filter, and you want to make sure it's still valid, right? Um, so filter not, and we're going to move that map into this filter. So given this we're doing conditions that drop I that take damage contains whatever, right? We're putting this whole thing into a list as all the same things, and it does not like. Yeah, we don't need this line here anymore either. There we go. Okay, and then now here instead, we take the memo matches, we get an index, and this index is like how far in. How much of the string we dropped before even doing the matching. So right, so I'm gonna do like conditions that drop I dot drop damaged and then drop one. So we're just gonna do a big addition here. I plus damaged plus one. Right, and now matches still works in the same way, but our memo match is memo on int, and this is, oh, what's this remainder is unused local definition condition. What happened here? Yeah, oh, we're just not using it anymore. This whole thing is a remainder now. Okay, that's getting better. Now I need to make sure like we're still working on these, which was working on almost none of them now. So we go through another round of debugging that. What do we start with? That was something really simple. So yeah, one. That should get us exactly one result. Um, that does not get us exactly one result. So in this case, we do have a matchable portion. And then, okay, we have this mix match. We're not going to be in here at all. We are going to have a first match though. So matchable.size should be less than damage. Do a print line right here, which we get here. In this case, we should get there. Okay. Okay, and then the cutoff is first damaged plus damaged, sure. And then memo matches is getting that. Let's print whatever's being passed to memo matches. With damage. Okay, so the issue is somewhere in a memo matches function. That makes sense. This hasn't been rewritten quite properly. I'm gonna do this lazy val uh, calculate. This could be all in here. And then get or else update it with calculate. Okay, so we calculate this, and let's think about, we have a first damage index. Do we still need this? Last potential. So because we've already done essentially this stuff here, we've done it below, right? Because what we passed to memo match is right here, we take the cutoff, which is first damaged plus damaged. Um, yeah, so the last potential conditions dot size minus damaged. I think there's a -1 here, right? Because we are leaving some extra afterwards. Like if we're matching 3, 1, 2, 3, 4, like this is the string that's going to it. Um, and the first damage is like at 4. Let's comment that out. But the first damage is at 0, 1, 2, 3. And our damage size is another 3. And our last potential is 6. 1, 2, 3, 4, 5, 6. It's going to be -1 in this case. The last potential starting place. Conditions at size. This is 7 -3. It's gonna be 4 -1. That's the last potential start. 0, 1, 2, 3. Okay, exactly. And if first damaged is not even in there. Oh, okay, hold on. No, this doesn't depend on first damage. So first damage is greater than -1. Then it's 0, 2, first damaged. Or last potential. Not to list. I think we start testing memo matches itself. And 0 to last potential dot to list, sure, those are indices. Yeah, let's try this. So memo matches. Let's say we pass a dot or, 2 question marks and a 1. List of only the 0. Because we decided like we aren't going to go too far past. Right, let's say our match was of a 3. Then there's, anything could happen after. It should get us a list of just one answer. 3 is not a suitable answer here, though. So we have to check if I don't know, drop by take damage that contains pound or like starts with a pound. Think again what the assumptions are here. So here we're passing a string to it. It is the smallest place where you can get a single match, right? It's like a whole area where you can potentially get matches. And we have to filter them out at the end, right? And make sure that when we drop however many we're dropping at first. So this index is like droppable. And it's droppable. I guess we're starting at 0. And we have to make sure. Let's test this on something even simpler. Let's say, yeah, let's say we do want something of, let's go even simpler. We have something of length 2. Dot dot. Um, there's a space afterwards. Should have one answer, right? And the answer should be 0. And that's not correct. So we had the first index of thing, and we assume. Oh, wait. Wasn't this matchable? So we first checked for like matchable spans, right? We checked that the matchable span is large enough. Um, okay. And then this is just a part where we filter out the ones. So like all of these, everything we pass in should be matchable. And I think we're gonna change our interface right here. Take the cutoff. What should our cutoff be? I mean, I think we should just pass in the whole. We pass in just a whole matchable bit. Why are we taking the index of the first damaged? Yeah, I don't like this cutoff here. The whole matchable thing to it. And nothing more. And we do the filters afterwards. So we have all these indices. We're going to do our filter knot here. So I make sure conditions. Let's do like a drop. This I that we're returning is supposed to be, it's just a number that we drop, right? The I dot take damaged. And then we need to make sure it doesn't start with. It doesn't start with a wall. I think I do want to have this condition be part of this, right? Like this is supposed to filter out bad matches. So we're gonna do like a starts with here. The drop I to take damage. So filter not starts with um, and then upon success here, we drop the I plus damaged plus one. And that's why we give it extra. Why are we giving it first damaged here? I think we just can give it the whole matchable area. Give it the whole matchable area. Plus matched. I do take here in case it's empty. Yeah. Okay. The memo matches. This conditions here is now just a matchable, right? It's a whole matchable space. Except we know that the last one is not necessarily matchable. So I think we can just take all of these as long as we're not going past this index. This is the very last index we could have as a starting point. So 0 first damaged. If it exists at all. Good, nice. Do you see where this is going? Is it going somewhere good? And have you finished tonight's problem? I'm gonna assume you might have. And if you have, you're welcome to join my leaderboard and push me down further. Um, these are starting indices for a cutoff, right? And why do I take the last potential? Yes, we take last potential because supposing there's none of this at all. Well, no. It could be taking the min of these two. So it's either we start the first damage or we start, or our last is even. Oh, this is just based on the length. And the length. So there's like an extra one padding on these conditions. This be conditions dot size minus damage. So like if it's 7 minus 3, sure. 7 minus 3 is gonna be 4. Our last potential here is actually gonna be like 0, 1, 2, 3. Right? So 7 minus 3 minus 1. Okay. So like that's right. Yeah. Wired. We found this, which is an index seek. Oh, we're gonna do a to list here. Dot to list. And we're still not getting like answers we like here, which is weird because I could have sworn like this was working for all these tests earlier. It's essentially the same code. Um, let's walk through this. 0 to, we have to start at 0. So it's going to be 0 to 0, right? Let's just print line the indices. And here we're going to get a 0 to 0. 0. And that like that has a size, right? That's just a list of 0. Cool. So why is it being filtered out? Well, conditions.drop I. So the conditions in this case is the string. Um, dot drop one. Dot take two. Right? Oh, drop one. No, this is a drop zero. Drop zero. Dot take two. Oh, hold on. This. Um. We also drop damaged. Need to make sure that. I'll start with. Okay, we're back to working properly here. Um, great. Now let's try, for example, um, this should have 0, 1, 2, 3, right? And it would never get past something like this, but this would give the same answer. Okay, and are all our matches things working properly again? Not quite yet. So matches 1. I don't know why that particular case doesn't work. Let's try memo matches. Um, just 1. Right, so our memo matches is working. This should also work for that, right? It should still, because it might be the case that that's all we could pass to it. We shouldn't do this based on conditions.size. And we shouldn't always assume the last one's going to be it. Or the last one's going to be present. I guess we could pass it like a matchable length. Yeah, we might need to. Yeah, okay, we could do that. So memo takes like an int out as well. Condition uh, matchable size damage. And now instead we do like the last potential is going to be matchable size minus damage. We know what minus 1. And here we pass on size. Right, this could also be like a Boolean thing, like whether or not we found something at the end. Or okay, matchable dot size. Here we go. That would get it working. Minus any like compile errors. Oh, we didn't pass in a new parameter, so matchable size. Int. Argument for parameter. Yeah. So here, like the matchable size would have been 2. Here, the matchable size would have been 1. Matchable size would have been 1. And here it would also have been 1. And in each of these cases, it should be 6. Even though, well, yeah, those are all realistic. Okay, and are we back to working on all of our tests here? So 2 size equals 0. Yeah, perfect. I should have made some of these asserts. But here, there are 3 potential solutions, right? Yada, yada, yada. Okay, now let's go back to testing. Oh, okay. So back to working properly for part 1, at least on the example. Let's see if we're looking for part 2 on the example. Yeah, back to working for part 1 and part 2 for the example. We're much more efficient now. We have a memo. Let's do part 1. Oops. Do part 1 on the real input. And we get the correct answer, 7916. Great. Take out whatever print line that was. Get some extra debugging. And then we are ready. Where's my print line? Where's that debug stuff coming from? Here we go, print line indices. And here is the moment of truth. Okay, it's working. It's thinking. 10 seconds. Let me try to put that behind so you can see how long this is running. 20 seconds. So far, not super promising, but we know at least that's correct. So there's more room for optimization. Um, okay, those large strings of question marks are still problematic in this case. Yeah, large strings of question marks are still like if there's no break at all. Oh boy. Didn't I talk about this earlier? How I should make sure I could handle those particular lines before doing kind of a memo optimization here. Give me one sec. Um, yeah, we're gonna cancel that. Cancel that. Well, and to still evaluating the worksheet at 50 seconds in so far. Gonna restart my worksheet. And yeah, let's handle a single line. Let's make sure. What are these? So 0, 1, 2, 3, 4. Let's try handle input 4. So right now I should only be computing part 1, which it shouldn't take 15 seconds. I don't know if there's like a warm-up thing. Okay. So input 4. Right. And we can do count solutions, parse input 4. It's able to do that. I wonder about like a parse 2 of input 4. Right, like that takes a little bit longer. Is that on its own enough to break us? Right, surely we can brute force like one line. And what is this going to look like right here? Big groups of question marks. So let's say we try to put 1 into a big group of question marks. I mean, suppose like we do like just a multiple of whatever n is. Part of the problem is when we get a long string of question marks like that, then we could choose, oh, by the way, did it complete that? No, we ran a heap space for that. Yikes, 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 yikes. Um, suppose we have just like a 1 and a 1. That we're trying to put in here, or any group of 1 and a 1. Or like here, is this another one? I want to look at some of these lines. Filter not contains this. Each print line. This is still returning the right answer. I'm out for now. Okay. Let's see what the output is here. Is it still stuck on a worksheet? I find that annoying that JVM dies like that sometimes. Um, we can do counts. We can do counts without necessarily knowing like what's remaining. Like my approach has been to like start with one, find all the ways that we can place one in there. And in this case, it'll be like all of those ways, right? Patchy says, what do I use to code? Well, I use so this is VS Code right now with the Metals plugin for Scala. And I'm coding in Scala. Look at some of these other examples. Like this one. This one's 4-4. That's kind of a problematic one for me to deal with, right? Okay, my approach has been to like go one by one on these. Return all the possible remainder strings. But then like we have to do the same thing with one for each of the remaining whatever. And sure, like there might be some memoizing, right? Like I could calculate, like removing 2, removing another 4. That will be reused in this and this calculation. Um, but I don't know, like suppose we just had like all these question marks, we applied multiple integers to them and we just did some math, right? Like count number of ways to partition this. This is a combinatorics problem. And I think I should break it down into that combinatorics problem, solve that, remember how to solve it. Um, and for each of those solutions, right, let's say I'm placing them somewhere in here, right? Let's say I know we can't place them here. And we're placing it just in this leading data question marks. I could say like, okay, how many ways are there to place it in there? I could opt not to take the entire matchable region. I could start, like if it's big enough. If the list of question marks ahead of me is big enough, I could take just that bit. And that might be memoized for whatever integer I'm passing to it. Right? And that leaves this as being, potential, I don't know. If I worked fewer if I worked with fewer strings, I shouldn't be returning whole strings. I should be returning indices. Indices for what's remaining. Let's refactor to that as a start. I don't think we want to be working with full strings anymore. So here, when we're counting solutions, final conditions. These are the conditions at the end. I guess final remaining indices. And we had to pass in this case, we had to pass in like the full condition string, I suppose. And we don't return a list of strings. Okay, so when I move forward here, a lot of my tests are going to break. So I'm just gonna commit here. 2023 day 12 part 2 for a break tests. Um, yeah, that's good. Now we're gonna move to indices. I think we have to comment out some tests. These memo matches are probably fine. Down here, all of these about to break. Count solution tests will be fine. All these matches tests are gonna break. Ah. Hmm. Okay. So we pass it a we were passing it a condition string and returning a lot of condition strings. I might not necessarily need to go there right away. There's still this idea of just taking this bit and like, sure, I can memorize this, but I can also do like math on this. The thing is, I still want to return indices for like how much it takes. But like that's a safe place to go for that, maybe. Try to match the one there. I mean, what if it's a bigger number, right? Like what if it's a 4? Um, where was that one condition here? There's a 4, comma 4, 4, comma 4. This one right here. If I did take a group like that, am I going to be missing out on something that starts here and merges into that? Uh, yes, potentially I have to watch out for that before I defer to memo matches. Instead of doing matchable, I could also do like a span just of question marks. All of the code remains the same. Dude, it has been forever. Yeah, it's been a while. It's been quite a while. Welcome, welcome. How are you doing tonight? Ah, yes, yes, yes. I know, I disappeared for a year. My last stream before this year's first Having a Code was last year's last Having a Code. God, no, I like sometimes showed up in chats, but that's about it. Um, yeah, Sleepy Goat, are you on the leaderboard this year? I don't know if you're working on Advent of Code. I'm doing all right. I'm doing all right. I think I just never got around to it last year. Like I thought I was gonna stream some projects. I guess I just got busy with work. But this year, I don't know. Like this is fun. I really want to take this in and stream some other projects of mine next year into January. We'll do them. You're you're not trying to get tired this winter, so you stopped at day 9. Fair enough. After day 9 or before day 9? AOC is fun. Oh, you're trying not to get fired. Okay, fair enough. Well, I'm currently trying to get hired, so that means if I sleep in a little bit tomorrow, we're okay. Hmm. And I'm trying to think. I don't know if you're familiar with what's going on with tonight's problem, but basically here, question marks. These numbers represent groups of hashes, right? And I'm thinking like there has to be some math way of solving parts of this. What I've been stuck on is an approach where like okay, I try to match something in and then I have like a remainder string. Are the groups in the written order? Yes, yeah, they are in the written order, right? So the first group is a group be a group of 4, yada yada. I've solved this for part 1, but for part 2, we start repeating these 5 times over. And then you have some like really big groups of question marks which which can be solved mathematically. Which can be solved mathematically and which really screw up my approach, which is to use like okay, I'll attempt to match these 4 for example, and then I'll just pass along the remaining string, right? So it's almost as if I'm like parsing this kind of a thing. Um, I mean, I'm sure there's like a closed form for this entire thing, but then I'm worried about cases like, oh, where is this? This one right here. So these are springs, right? And these are conditions of the spring. So here, this is a set of springs. Um, pound means it's damaged. Dot means it's okay. And a question mark means you don't know if it's damaged or okay. So this is saying there are 2 groups of 4 in a row damaged springs. The first group has to include this pound, right? So that with that 1, 2, 3, 4. And the second group can be anywhere in the remaining stuff after that. a game of Kakuro. I'm not familiar with Kakuro, but thanks for bringing that up. Let's do a quick detour. Kakuro. Oh, okay. Yeah, let me know if you think it's actually the same. But always happy to learn about new math games. At least in the case of ones. Let's see if we can solve like this bit. Let's say we have 10 question marks, and we can be anywhere within that range. Then for a one, there are 10 places that can be. If there are two ones, then you get 10 places for the first. Um, and depending on where you place that first, there might be 8 places remaining if it's like right at the start. But if you place it anywhere in the middle, then you take up 3 spaces because you can't be adjacent to it. It's like reminding me of something. Um, it's a grouping problem. It's a recursive grouping problem that has a name, and I know it shows up when you're like optimizing matrices. Let me look at let's say optimizing matrix calculations. How many ways are there to group it? Let's see. What calculation order? Let's look at some of these and see if I can remember what the thing is. You're thinking about a nonogram. Let me see that. Okay, yeah, kind of like a nonogram. I see where that might be. Matrix chain multiplication. Um, to grasp context, let's start optimal order of multiplying these matrices. Okay. So you could do AB, you could do BC. There are two orders there. Sure. But now, so like this is also sort of a grouping problem. Maybe it's tickling the wrong bell. Anyway, that was the problem I was thinking of there. Um, but what is this problem where you're partitioning this? And like each partition can take a different size potentially. I mean, I suppose we could have like a phantom piece here at the end. No, no, not quite. Again, if I were to memorize this, for one, like just take a group of question marks and memorize that. I have to worry about the case where whatever, like if it's bigger than one, hmm, dare I say I don't know. I do dare. Why don't we run through some of these? A lot of question marks. Group of one, just the matches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure. and 1. And then dot size. I feel like if I were to able to do this in such a way where I just where the count is all that matters and not like the remainder strings, then perhaps, well, then I have to do like I have to do it for larger groups of numbers. Not working. Right, like, okay, like this is pretty straightforward here. Um, oh, you know what? There is some duplication. I see some potential duplication because we might choose to put the 3 anywhere in this whole range, right? But for each of those, we might then also branch, right? We're matching here. If matchable, that distinct. We're only doing that though in the case where it's all question marks and we can skip past the next period. So I don't have to like really worry about that case there. Um, Again, like what happens if we're doing this like multiple times? Then for each of these matches, um, flat map matches with another 3, and that size, 10. There are 10 ways to put 2 3s in here, which I believe that. Let's print line all of those. And these are the remaining tails. Okay. Interestingly here, like for each of these, a lot of them have the same end result. Right, so we can just multiply the ways for each of those. Um, Great. So what if we had a map, right? Like we could remove those duplicates. One, like, I mean, we did have memoization for handling duplicates. Like each of those paths will go down a lot of duplicates, but also that number of paths could grow a lot. So let's handle that here. Um, Instead of a list of conditions, we have a map of conditions to the number of times it appears. And this is now called condition counts. Okay. And then now we take our condition counts. We're not gonna flat map that way. Exactly. Let's start with a map. Case conditions and a count. And then we're gonna do like matches. What are those conditions and damage? Hmm. And all of these get that count. And then we have to like merge, right? We gotta get new map accounts. Okay, this here right now is a very easy programming subproblem. I'm just tired. Ugh. Okay, so we look at all the matches and all of these things will get multiplied by the condition. So like this these strings here, we're gonna do like a group map reduce to get the counts. And key is identity to one, add them up. And I don't think it's gonna be quite just to one. Um, oh yeah, sure. So we have the counts, and then we multiply all those values. Um, counts dot view dot map values times count and to map. And then of course like we're merging maps. I think we just want like some of these others might end up running into the same strings. All this in about 15 minutes in closure. Well done, well done. Um, I'm missing insight. It'd probably take me this long in closure as well. But anyway, right now I'm doing some big deduping on my solution counts. How's closure these days, by the way? It's been a while. I haven't followed any conch talks. Yeah, part two. I think I just need to do a lot of deduping. Uh, so like we have a bunch of strings to their counts. For each of these, we're gonna have a bunch of strings to their counts, and I need to merge them. Um, so we're not gonna take this to a map yet. Val, I don't know. All counts. We can take these counts that I guess we can get this to be like a list of tuples, and then this can be a flat map. Oops. Rura 83. Are you on my leaderboard? Because I'm curious to see how you're doing for the rest. If you join, you can bump me down even further. Okay, and then we take all counts. And then we're gonna group by just the name. And then we're gonna map the values. Um, and for each of those values, we're just gonna take the sum. So map case conditions counts. Counts here is a map of string to int. That's interesting. All counts. Wait, all counts is a map. Oh. I don't think I wanted that because you don't want to accidentally merge things, or like overwrite things. Okay, now we just have a bunch of tuples. All counts is a list of string to int. So string to int, we take our conditions, we take our new matches, um, we get counts on those. And we do that because we do still need to multiply that by whatever the previous count was of that map, right? Okay, so now this counts is a list of a string and int. I had meant to flatten that, so all counts is a list of string to it. Oh, sure, great. Um, yeah, just the right hand side. Get all those counts and we sum them up. And then this whole thing, okay, we're getting really lazy about how we write things. It's getting late. This becomes the new map that we pass along in our fold left. So that dedupes a lot. And final conditions is a map from string to int. And we filter out some keys. That view dot filter keys, and the key should not contain, so not key dot contains a pound. And then we take the values dot sum. Okay, let's check that this still works. Structure your recursive function correctly, there's no duplication. I believe that. I'm gonna be worried about reading. I made a recursive function. I don't want to spoil myself too much. That returns a. Oh, I can't read that. A count solution for the remaining substring wrapped in memowise. Okay, I'm memowizing here. So my approach here, horribly long. Yesterday it was like 15, 20 lines of code. So I have this function. I'd gone with the recursive function at first, and then like went to trying to make it tail recursive, so I don't run out of memory. And I decided actually let's just cut things out. So this is my smallest unit here. It just gets like the first match, and this bit here is memowized. And now I know I'm memowizing and deduping, which is like they kind of serve similar purposes, but I really need to prune my tree. Let's just check if this still works properly. Okay, at this point I've like broken some of my counts. So what did I change? I just changed this here. We change this to a map of a string, the number of ways to get that string. I'm gonna go to sleep, I'm gonna wake up, and I'm gonna realize I could have simplified all of this. And obviate the need for a lot of this code I've written. I know how this goes. I'm so tired. It's almost 5 a.m. here. Okay, so we have our counts. It's true. Memoizing is, yeah, that's why I say there's some like duplication here, right? But it's still like Hmm, you're right. Like I'm kind of doing the same thing twice. This memoizing is not quite enough though. So I think I might be memoizing at the wrong unit. And actually the problem. So the problem here is like the unit at which I memoize um, is too large. So here in my matches, I span across like what's matchable so far. And if and this works great in cases where I have periods, right? To break things up. And that works. But then in the case where I have like all question marks, then what it's memoizing is like a string of length, 50 or whatever of just question marks and a few pounds scattered between. Which is I think why I started doing this other approach instead. Let me think about this. If this is solving the same problem that my memoizing is solved, then this would be kind of a waste of time. But I think I had the impression, what gave me the impression that this difference here. This takes at each step. Like our condition string could still be really long. I need a smaller unit at which to memoize, like smaller prefixes. The only problem is when I do that, like I wish I had a solution that worked more mathematically. Did combinations, like did some combinatorics on like a smaller set, and then multiplied them. Just multiply like a list of counts. But the problem is like when I do a match, my return is essentially okay. I match this, and these are my potential remainder string. Is this going to solve my problem with a big string of question marks? Is the question right now? And I think no. Right? If conditions is a big string of question marks, then I still pass that to matches. And within matches, this here is relevant. I pass on this large string of matchable to my memo matches. And I end up passing many of those strings. I mean, it does still do some pruning. Like, say I have like 10 question marks. I might match into the first two or something, right? And then I drop each of these. I drop. Um, right, so like I might drop to two, and in one case I still have like maybe like I have another one to match against the remaining. Let's see. Let's look at a concrete example. Day 12, 2023, not text. So like this one here, right? We might match the first one to that, and this might be a remainder string. Um, but our first one, we try matching it in many of these places. And so we calculate essentially like one for all of these starts here. Um, and then we get to our second one, and like, okay, yeah, these have already been calculated. We get our next one, these have already been calculated, etc. Now, this is a place that could be broken up specifically for the case of one, where like it's not going to be in here, right? So the minimum area is even smaller. That could be helpful in breaking up my question marks a bit. If I pass smaller things to memo matches, that would be a smaller thing to pass to memo matches. Um, yeah. Yeah, same call arc, same results. Exactly, right? Um, so like there is some of that, right? Like the second one, this third one would see a lot of the same stuff that the first one went through when it's operating on like the leftovers of the first one. But I do think I want to memorize something smaller. That way I can reuse it in the repetitions of this. So let's look at more of these strings and see. Okay, so these are all my strings that don't have dots. In this case here, we can split this up here, right? That's as far as a one match can go. And that's the unit that should be sent to my memorize. And here with 4, we are kind of bound by that first hash that we see. But let's say, we get after that, we have a bunch of question marks. We're not necessarily bound by that first hash anymore, but we go all the way up and through it. So we could end up getting a long string. Oh, I mean, you can only go so far past the next pound sign. And I guess I am doing that, right? I'm not letting you get past the pound sign. In fact, I think I'm also not letting you get past the next pound sign here. Let me make sure I'm doing that. There's some point at which I look. I don't feel like I'm memorizing stuff in the middle. I'm memorizing from the start, and I might see the same start multiple times. So I guess in that sense, it's in the middle. Um, let's look at this. I'm going to change my code back right now. The counts code. Uh, da, 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 da. Let's go back to what we had originally. So final conditions equals nope, we don't want all that. What we want is just the conditions here. I don't like this naming here. We just take conditions. What was conditions here? A string. Was this a list of string? I think this is a list of string. And then we take conditions.flatMap matches. There we go. And then at the end here, we just make sure none of those final conditions dot filter not contains found, and then not size. So this should get back to working properly. Oh. Mm. I just need to do a big undo. Let's just do some undos until we're back to working again. We'll save some of this code though. Okay, I'm gonna backtrack a little bit before I try that. We're almost there. Okay. Now at this point, this still works, right? Or maybe I get revert where I was last. What are my big diffs? I'm gonna save some stuff in Scratch. Okay, and then when I get back to working code, my goal is to check what I'm passing to my memo function. Um, let's see. Unstage changes for day 2023, day 12. Are there no unstage changes right now? I don't believe that. Um, oh, I think what I've been committing. I think I've been repeatedly, yeah, I part two worksheet is not in Git. Okay. I think we just do more undos until we get to that point. Where I was last working. Oh, that's really annoying. Okay, we're doing some like exploration here. Okay, and then we were like commenting up a bunch of stuff that we might not use. At this point, when we're commenting out tests, I think things were working, right? No, no, no. Oh no. I didn't have it committed. Okay, well, we can probably remember where we were. Um, yeah, these here should have solutions. We're just getting indices. Job starts with. We have a matchable size. Oh wait. Okay, no, that's correct. This is a list of 0, etc. Okay, so here, what's not working here? Size of that should be 1. Yes. This has 3 solutions. Yes. Matches no solutions. Great. Great. 1 solution, etc. This has 1 solution, 2 solutions. Um, Wait, we're matching a length of 2. Yeah, okay, 2 solutions, 3 solutions. This here should have 3 solutions. No, it just has 2 solutions. And this also should have just 2. No, this can have 3 solutions because you can just match in these first 2. Okay, well in that case, why is it not looking for these? Well, okay, let's go back to debugging. Let's just debug this real quick and then we'll look back at our memo. So input 0. Oh, wait. Let's make sure this is actually working on the example. Okay, yeah, okay, it works. It works. It works on the example. Um, yeah, we're at a point where we can test. Cool. Right, so I commented those because I was about to go stuff that's more performance heavy. Okay, and then we have like problematic lines, like line 4, and we want to test on those. But now, memo matches. Um, what we're passing to it might be too large. Okay. Um, it matters how many of dots it contains. So if we're gonna draw from the right, we'll take it the most. Um, unmatched dot take 1. I think if we could just change what we call unmatchable and unmatched. Um, and we find, what we want to do is find like the final index. And then we can do a split at. And final index could be like the minimum. Yeah. Now index is going to be a minimum of a few things. Let's find like the index of the next dot. Um, well, undamaged, working. Yes, those lists are problematic. Um, I did turn them from list of strings into a list of ints, but still, it is a lot of memory. Um, but before we get there, I just want to get smaller pieces that we are sending. Okay, so you're well into the long range for P2. See, well, what I'd like to do, and I've mentioned this a few times in various contexts, I would like to manipulate different like count ways, like using count ways recursively and like summing, multiplying, whatever, any of my count ways. Instead of just saying like, okay, this is the remainder. So this list of int represents my indices where we continue. And I don't like that. I don't like that. Um, that's what I have for now. I'll get back to that thought. So conditions index of the next dot exists. Um, at this point, I've stripped all the leading dots. Oh, yeah. We had done that in some sense here. But we also want to know the index of the next pound, which we all like. We use the index of the next pound here, but we don't use it very smartly. Like this tells us where the last match could potentially be, and this is here happens to be useful in the case where like matchable size might use that. But if we have a group of larger, I suppose, larger than our next damage, so let's start damage 1. We have a group of 2 of those, then we absolutely want to stop before that, right? Um, yeah, so the next dot is a potential stopping place. And val, I don't know, let's give this a name afterwards. This is conditions index of, uh, let's do pound. You can multiply strings in Scala, right? So let's do times 2, yeah. So if it's greater, let's do damaged +1. Then that's a potential stopping index. We have to stop. Okay, to sort of match that, we have to stop 1 before that. So we can do like a -1. Okay. Um, well, I don't know. We're giving things random names at this point. Uh, and then min match limit. So whatever the minimum of that is. And we split at that point. And again, let me just do a split at. So if we split at 4, I think we'll have right the index of A. Then A is included in the remainder. Okay, so we can just do conditions that split at I. And then this gives us something similar to whatever that is we were using before. And now this gives us more cases. There's smaller inputs now, right? At least in some cases, in the cases where we have something like this, like a hard limit on how far we can reach. And then we could also fit this in, right? First damaged, and we can only go so far past that. And again, these are only if these are not -1. Um, so I don't know. I wish index sub gave me an option here. Then I could work with them only like if they exist. I suppose I could turn. I need to ignore negative ones. We'll find out a way to handle those generically. Well, first damaged. Index of pound. And we get to like that plus damaged. That's as far as we can match. -1. Right, the index of the first one. And let's say it's one length. If we subtract one, then we go to the piece before. No, okay, plus damaged. So in the case where we have dot 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 pound dot dot dot, right? If damage is, we have the index of this, um, damaged gets us up to here. And I think we want to go up one past that. And just to check, if we do like a split at something way past, so like Stewart that split at 14, right? Okay, that's what was expected. So that index +1, and then we just do a +1 at the end of that. Plus damage +1, right? And if damage was 3, +1, oops. Now that refers to, well, actually I think we just do plus damage. We don't do the +1 because we want to refer to this piece afterwards. So whatever this index is, plus the length 1, 2, 3, yeah, that gets us there. So you don't have a +1 here. Great. Now we do a big min. I guess I could do this. Each of these, I'm just gonna give myself a little helper here. Def neg1 to if. So given some n, int, if n is less than 0, then integer dot max value else n, or rather if n equals -1. We'll just say neg, we'll just make it shorter, neginf. Cool. So neginf working, min match limit, not min, first damaged. And I guess we need to neginf all of those. And I guess for good measure, we'll do like min with, send me a list of, this be a list map neginf dot minimum. So let's just do that. List working measurement. Oh, filter greater than -1. How about that? There's an idea. Yeah, dot min. Okay, that works. That works. And for good measure, like none of those might be found, right? And these two kind of end up, I don't know. I wonder if they end up sort of serving the same purpose. Okay. My tests should still work. I should turn those into certs so I can actually see if it doesn't work. But that seems to be fine. Some of these, 113, that gets 4. Yeah, sure. I'm not confident that that'll be especially more performant, but it might handle my special case. One of these. So day 12, 2023, 0, 1, 2, 3. Let's try to handle input 4. So matches input 4. And let's just do, let's just try to straight up solve that. So count solutions, parse input 4. Make sure we're getting the right one. That's fine for part 1. Parse 2. Not fast enough. Of course it isn't. We are getting like smaller things going there. Let's print what my arguments are as we're running that. Uh, Maybe let's not do it quite on that. We had to find another parse function that just doubles it instead of tripling and quintupling it. And then we can do some debugging, see what was passed in. So parse, let's just say double. Parse double. Replace that 5 with a 2. And let's add some print lining on our matches. Maybe on our memo matches? No, let's just do it on our matches. Well, no, we do need to do it on our memo matches. We want to see what's going to the memo. So go to memo matches. Okay. Now, oh, I don't know what that's running on. This should work fine with 105. And we want to do this with parse double. Oh, give me 1 sec here.